Hello everyone, and welcome to our 2023 Data Conference. I'm Ivan Kravtsov from EPAM's Data Practice, and I will be the moderator of our engineering stream. This stream is focused on deep technical knowledge and expertise and features our best experts from EPAM's data analytics practice. For the first talk, let me introduce our speaker, Head of Search Competency, Principal Software Engineering in the Data Analytics Practice, Perikov. He will dive deeper in the LLM application in modern search and cutting-edge realm of search engine technology, how integration of traditional and vector similarity search methods is revolutionizing information retrieval. Please remember to post your questions in the YouTube chat or in the QA session of We Are the Community. Our top 3 questions will get valuable prizes, and top 10 will be posted on the Hall of Fame. So, we all ears. Konstantin, please.
Hello, and thanks for the introduction. So yeah, today we're talking about LLM's role in the modern search strategy. So we'll be focusing on how the addition and this year 2023 hype of the ChatGPT and whatnot changed the landscape of the modern search implementations. And as Ivan already said, I'm Konstantin Perikov. I'm a principal software engineer at Data Analytics Practice. And for the last 10+ years, I've built in various information-driven implementations, information-driven systems, to be honest, for almost any domain that could exist in the world, starting from classical e-commerce search to the more scientific domain of the search, patents, publishing, and various even complicated stuff like cheminformatics search of the molecules. So what we're going to talk about today. So first of all, we're going to start with a little bit of foundations of the search. So we're going to discuss and talk what are the cornerstone of traditional, let's say, search implementation, something that you might already know, but I wanted to recap it really quick. Just to make it fun, we're going to look into some of the possible implementations using Python. So we're going to have some code snippets from the Python stuff that you could adopt to any programming language of your choice. Then we're going to look into some of the challenges that those traditional implementations have and how we're battling them in the past. So this is where we're going to talk about how semantic understanding advancement changed the landscape of traditional, let's say, keyword phrase search. And then we're going to combine and see what the actual hybrid search means, because these days everybody talking about hybrid search. So how to combine large language models, embeddings, vector search, plus traditional filtering, geo search, and whatnot. And we're going to take a look at some of the examples taken from the real projects with actual challenges that we found and faced. Once again, we're going to talk a little bit about how to implement this, how to use these methods. We're going to take a look at some of the data quality issues. So it should be very, very interesting. I hope you're going to like it, and please stay till the end to ask your questions. So if you're going to start in with the foundations of the search, right? So this is, once again, a very, very straightforward, very traditional, but one of the very important parts of any information-driven search is actually breaking up the text into different types of tokens, and this is what is called tokenization, right? So this is where basically we breaking down the text into smaller units, right? They called often tokens. It could be words, it could be phrases, it could be even characters, We could talk about more sophisticated tokenizers that exist currently right now in the world of a sentence transformer, BERT models and whatnot. And it's a fundamental step in search technology, right? Because it's actually enabling search engine to process and index first of all, the vast amount of data in the web or in any type of system that you have. And by tokenizing, we could organize it efficiently into inverted index, some additional structures like doc values, postings list, term frequencies to actually retrieve those information very efficiently, very fast, and work with the various amount of data, looking into like even petabytes of data. And this one, very straightforward. We have a text here, the cat sat on the mat, and we see how we could separate it into tokens. So in this case, we're just using a white space tokenizer, for example. And to be honest, to implement this would be as simple as doing something like this. Once again, this whole presentation is in Python, so please take a look, but you could adopt it to any type of languages that you could use. So here we're using the lowercase just for consistency, and then you just strip it based on the space if there is no alphanumeric characters with the space, basically. And it's very straightforward, exactly as what you would expect. If you have some example text that, tokenization is essential, and example text, we're going to see 5 tokens in this case. So we stripped all the punctuations, and we just separate the text by spaces. Very straightforward. There is some other, obviously, more advanced ways to tokenize, and one of the go-to library these days in Python is Spacy, and probably one of the most powerful NLP libraries, at least there, that open source and available out there for a lot of different languages. So you could use more sophisticated libraries like Spacy, for example, where you could load some of the tokenizers, for example, from this web small model, actually. So you could use other types of models that exist in the Spacy, which provides higher precision, higher accuracy. In this case, there is a transformer versions of the model, which are not trained just on the web, but also on different types of general purpose text, for example. And first of all, we need to initialize the document using this construction, NLP at text, and then basically receive the text. We could take a look how this Spacy is a little bit smarter, I would say. It's handling a little bit more complex cases, complex options like contractions and others. For example, we could see that here we separate clearly e.g., so we understand that this is actually a kind of like a keyword kind of token, right, which have a meaning. Similarly, we do this with a don't. It's actually even more smarter way of parsing, where we separate the don't into do and not, once again, to handle it more properly, to have this negation option. Once again, as for all of these tokenization methods that we're going to be looking a little bit through, each of them have some strengths and some different levels of complexity versus accuracy. So of course, this requires some testing, some trials and errors, and some experts' opinion on this one. Since we're talking today heavily about search engines, how to use them in combination with large language models, in combination with vector search, we couldn't just not talk about what tokenization is available in search engines. And very often in these out-of-the-box basically solutions, even open source solutions like Elasticsearch, OpenSearch, Vespa, there is often different types of tokenizers, and to be honest, even language analyzers that exist out there. You could use them out of the box, once again, working for most of the languages. And while it's nice that it's coming with the product itself, it could support some more complicated scenarios. And here, I'm afraid there is no examples here on this screenshot that I've taken from one of the documentation. But basically, it could be more sophisticated tokenizers that are trained on the email tokenizers, for example, right? So they could be properly handling emails or URIs, and basically being even language specific. So very often when we're talking about languages, English or any other more well-known languages have more straightforward tokenization, very often space-based or delimiter-based. But for example, if you're talking about CGK languages, so Chinese, Japanese, Korean languages, for example, their tokenization is very much often much more complicated. It's not space-based, but are rather kind of like word level based in the big kind of word. We have similar examples in European languages as well. For example, Dutch or German tend to have this property of the language where you could, without any issues, to be honest, just concatenate those words all together. So metallic condensators actually in English could be 2 words, but in German, for example, very often you could have a 1 word which would be like metallic condensator. So tokenizing those languages sometimes could be challenging. So it's a very big advantage to have them available out of the box in a lot of these open source, and to be honest, not open source search engines as well. Usually, big part of the linguistic package. Once again, very good to have them. We could use them from the Spacey in the case of the search engines, but very nice to have it on the side of the product itself. So to have it easy in terms of integration, for example, with the indexing part, with the querying part. So definitely something to take a look at. Last but not least, definitely, since we started looking more and more into more sophisticated models, into large language models, or just language models in general. Not even talking about, let's say, about ChatGPT, but talking about BERT and whatnot. They revolutionized one of the tokenization methods, which is called, for example, byte pair encoding, BP, or word piece, or sentence piece. There is different implementation that used heavily in the large language models. And in this case, it's very important to remember 2 things. So first of all, if you're using, let's say, any type of transformers, you could always get tokenizer out of the pre-trained model, basically. You don't have to train your own tokenizer very often. You could just use it. And for example, here we tokenized a little bit more sophisticated string, to be honest. Like everybody's an expert in LLMs now, and I'm using some emoji actually. And you could see how the tokenization works in this case. So most of this stuff is very straightforward and similar to what we see in Spacey examples, for example, because we just separate them by spaces, we preserve the punctuations. But I would try to show you like a little bit of details here. So first of all, LLMs. So those byte pair encodings or tokenizers very often are dictionary, kind of like dictionary based to some extent. So they might have some tokens which are unknown to them. So in this case, unc is a explanation of the unknown token. So in this case, this emoji is unknown for their so-called dictionary, let's say. And also we have seen that LLMs is something similar in this regard, because it's probably not trained on words like LLMs as well. So we see we separated it for 2 options like LL and actually also masked version of LLMs as well. Why it's done? Obviously, we're not talking much today about BPE tokenization and how it's working for different implementations. So I would rely you to go to some learning resources like Hugging Face and actually check on the masking, for example, and how those tokens work. Once again, very important. These tokenizers playing a pivotal role in the large language models these days. You want to make sure that you're using the exactly tokenizer that was used for this model. You don't want to have some sort of mix and match, because if you're gonna do this, most likely you're gonna not. I mean, everything is not gonna work properly, to be honest, right? So this is a pivotal thing. Another thing important, especially with the ChatGPT, let's say, and API-based large language models, this is exactly or very similar how we got into this price per token, right? So everybody's talking these days about price per token, how to estimate how much I need to pay for my ChatGPT or any other type of large language models available by API. So token estimation is definitely one of the options, and this is where those tokens are coming from. So in examples of the Latin languages, we see that tokens are mostly, once again, words with some exceptions. While for some other languages, for example, like some Slavic languages, very often a token itself represents actual character. So this is some sort of limitations the bytes pairs and how they need to be fitted into the dictionary. So this leads to the funny situation that we're using non-Latin languages, for example, the number of tokens being used for API-based LLMs is actually increasing quite high. So that's something to watch out if you are not supporting just English or let's say Latin languages. Obviously, there is tools where you could estimate those number of tokens. So first of all, you could run those tokenizers and just calculate them. So this would be quite accurate as well. Another one is a tools like tick token from OpenAI, for example, and similar from other providers as well. So this was about tokenization, right? So tokenization is the first very pivotal point before we could even go into any type of information retrieval system. After the texts are tokenized, the next step is actually creation of inverted index, or to be precise, let's call them postings list, because that's what they are. Inverted index is often these days umbrella of different types of algorithms and structures. So here we're firstly talking about postings list. And postings list is basically a data structure where a term contains like information about where these terms occurs in the across the different documents, across the corpus of the different documents in the data set. And it could include some information like document ID, like term frequency, maybe position, and some extra possible information. And before we even get started, like you're probably thinking like, I never heard about like postings list or like inverted indexes maybe, but in fact you are. So this is an example here actually of the classical postings list inverted index structure that you could find at the end of the book, right? So this is just index at the end of the book with the keywords and pages that they mentioned. So you could think about it similarly to the postings list or inverted indexes. And often we could create the inverted index using those search engines, for example, once again. But for the purpose of today's talk, we're actually going to take a look a little bit ourselves into in depth how it looks like. And imagine we have two documents already tokenized, right? This is very important. So this is a sample. This is another example sample. And very basic, straightforward postings list would be just iterate across the document, across the tokens that exist in those documents, and just add them to the doc ID. Right. So, an example would be exactly as you expect. So for this term this, for example, we know that the document IDs are 1 and 2. For term A, there is only 1, and for another example, 2 and 2 and things like this. So basically, this is a very oversimplified, of course, example of inverted index. To improve actually the search functionality, right? To actually support much more sophisticated scenarios, we want to add some additional information to this postings list. For example, term frequency. And term frequency could be used, for example, in relevancy scoring. So one of the, once again, very classical, very even I would say outdated these days concept is the TF-IDF approach, right? Where we have term frequency, how often the term is existing in the document, and IDF is inverted document frequency. So how often this term exists across the other documents. So basically, the motivation is very straightforward. The more term appears in this document, that probably means that this document talks more about these concepts, while the less it appears in the document corpus itself, then it means it's more rare, and this document represents this term kind of better. Once again, a little bit classical, a little bit outdated these days. I would say we're gonna take a look how to make it better. And in terms of implementation, we have something similar again: apple banana, apple banana, apple banana orange, and we're following exactly the same approach, but instead we also are storing the frequency of the term. All right, so we just summing up them. Very simple, very straightforward. An example of this posting list could be something like this. I just printed it for clarity. And here we could see the term apple, and it exists in document 1 with a frequency of 2. in document 3 with the frequency of 1, and so forth and so forth. All right, so we already have this extra, let's say, statistics, term statistics that we could use. Another improvements over term frequency could be actually storing the positions. So what positions in the document they exist. That's very important for so-called phrase queries or proximity searches. So you could use it actually in order to find two words next to each other or specific phrase altogether. So this is how you could do this. And once again, very straightforward. Iterating over tokens, we would be storing document IDs and positions as well. An example would be exactly as you would expect, that an apple exists in document 1 and appears at position 0 and 2. And similarly for others. So all of these components, of course, in the real world, are combined all together, combined jointly. And to be honest, we would add even more sophisticated things like doc values that help in our filtering, sorting, aggregations, or faceting implementations. There is more on the side of statistics, how we want to preserve those statistics, term frequencies, how to make them scalable. But luckily, it's not a purpose of today's talk. So we're gonna take a look at the last cornerstone of traditional search, which would be a Boolean search. And it's once again foundational approach, and it applies logical operators such as and, or, and not, and to basically create a complex search criteria. Very often we could say, apple and banana. So we want documents to contain both apple and banana somewhere in the document. So we could use or and so forth. And just to remind you of the classical Boolean logic, how it looks like, and or not. And implementation, to be honest, using our postings list, right? So once again, you see how we building this on top of the already existing foundation, where we could go to the postings list, we could get a set of the documents based on the term by this postings list and just join them together. So for and, we could do intersection, for or we could do the union, and so forth. Why this is important? Because internal implementations of those postings lists are very often a little bit more complicated than that I showed you. And it contains various bits operations, right? Rather than, let's say, byte level operation or integer level operations, to be honest. So we really intersect in something like a bitmap. So probably some of you heard about roaring bitmaps, which is like probably the most advanced bitmap concept at the moment, and probably one of the fastest implementation these days, that allows exactly those fast intersection of, let's say, different bitmaps. So actually, in order to find the matching documents, it's very, very straightforward. So basically, after we discussed, let's say, classical building blocks of the information retrieval system, we think like, do we think it's enough actually to create the proper modern search system? And actually, in fact, it's not, right? Because this approach is all quite limited to some extent, and modern information retrieval really requires a much more sophisticated approach, right? Nobody would like to use like Boolean operators or whatnot, right? To be honest, based on our experience on the projects we have, and we see less and less implementations where people tend to have something like Boolean filters or a specific phrase. Everybody's moving towards, first of all, natural language understanding, so more natural language type of queries. But it's not just let's say the hype of natural questions, but also all of the complicalities that exist around. So let's take a look in how advancement in semantic understandings were helping us to implement those more sophisticated concepts. And once again, some challenges are contextual limitation in the words. So all of the building blocks that we were discussing wouldn't really help us understand the nuances or polysemy of the words, right? So if you're going to use the word bank, it could mean a lot of things if used without any sort of context. It could be bank as in river bank, or it could be something like a savings bank, like a loan bank, like a credit bank, I don't know, and there is really no way to capture this meaning, at least with the traditional building blocks that we were discussing before. Boolean logic, once again, sometimes are very powerful if used properly, but often could lead to difficult situations where people are either put in strict conditions with ands and nots, or some other challenges. Last but not least, with the rise of voice search, conversation interfaces, chatbots and whatnot, people tend to ask more natural language type of queries. There is a definitely a shift in the customer's behavior. So before they would be using words like t-shirt, now they want, oh, I want classy t-shirt for the barbecue party, right? So those natural language queries also posing some of the challenges to address. And let's take a look how to solve some of those challenges once again, how you could do this. And one of the classical ways to deal with the contextual limitations and polysemy, for example, is to use something like a synonyms list, and to be honest, more ontologies taxonomies part, right? To be honest, falling into category of knowledge management in particular. So this means that we want to make sure that this inherited information that, for example, pesticides in this case are part of the agrochemicals broader group. This information really helps us to do the keyword expansion, to do the synonym matching when the users are using a different type of words, or maybe unknown type of words. So, for example, if they want to maybe mention poultry, then it means that maybe they're talking about chickens, maybe they talk about ducks or gooses or something. Of course, there is still a challenge that creating of those ontologies and taxonomies is a complicated job, complicated task, to be honest. And one of the great advancements, for example, in LLMs, in usage of LLMs, is that actually LLMs could be used to parse and extract those facts out of the large corpus of text, right? So this is definitely one of the, let's say, less traditional usage of LLMs. But it could be used to actually extract triplets, extract facts, extract a connection between those terms. Very, very interesting approach, I think, to speed up the knowledge management. And there is definitely a couple of streams, I think, on today's conference a little bit later, which are talking about those knowledge management concepts as well. And I imagine we have this synonyms list. Some implementations of the synonym matching could be quite straightforward. We could have, let's say, oversimplified synonyms list, where bank is a financial institution and river bank, and river, for example, is a water course, and money is a currency and cash. Different types of relationships. And we could combine them and you actually enrich postings list with this information, so later it could be searched properly. Second thing that we were mentioning is like this complicated Boolean logic plus, let's say, these keyword concepts, right? So very often we were looking specifically into keywords or tokens that exists in the original text, right? Like apple, banana. So like, but what people are, what to do if people are actually doing misspellings, right? So if you type banana instead of banana, for example. And a traditional search implies things like spell checking, for example, where we could deal with those. And that's definitely an option. You could use like approaches like Levenstein distance and whatnot. But a little bit later, we're going to take a look into how LLMs are affecting spell checks, because these days often there's the claims that if you have a LLMs, implied, or have a vector search, vector similarity, you don't have to worry about misspellings. Not actually that much of the true, so we're going to take a look a little bit later. And fuzzy search, straightforward implementations on the Levenstein distance could be something like this. Once again, a little bit of explanation of how this could be done. So we're using the query, we have existing postings lists, and for each term in the postings list, we're just comparing the Levenstein distance and see if it's less than threshold. In this case, it's 2. We're going to be adding these matching documents. We could have even more sophisticated ways. We could even have more like auto-suggest type of thing. but we're not going to take a look into examples. Last, maybe, but not least, is if you're talking about more traditional, let's say, NLP, something like early days NLP. And early NLP systems rely heavily on rule-based approaches, or maybe specific rules for specific natural language queries, or using any type of statistical techniques, right? Like creation of the n-gram models, for example, which are actually were foundations for the current large language models, right? So this was the let's say a previous generation of language models. Even they weren't large language models even before. So definitely something you could work on. You could combine all this statistical likelihood of some n-gram or some part of the word appearing in the corpus just based on the statistics if you would be analyzing a lot of different texts. However, it's still struggling to understand, let's say, concepts like polysemy. And here, actually, all of the images in today's presentation are generated by DALL-E, generated by ChatGPT. I know it's very popular these days, but yeah, I couldn't resist, actually. And to be honest, I like some of these pictures. So this picture really represents a polysemy, so like classical problem, like what apple means when people are asking, do they talk about fruit apple or do they talk about a technology company Apple? And one represents a technology company and one represents more like a fruit type of thing. Of course, this is not the all, let's say, like traditional or cornerstone NLP approaches that could be used or should be used even in search implementations. We're talking about stemming and lemmatization to actually reduce maybe words to their base or root form, helping with some of the formulation of the queries challenges as well. We could talk about part of the speech tagging, for example, where we understand what part of speech this token is. Is it a noun? Is it a verb? So this could be used actually for some specific logic to understand the connection between the words, right? Because the phrases are usually created in according to some rules, to like language rules, grammatics in this case. Once again, not a precise, not a concise list of all of the possible challenges. This would take me like 2 hours to talk about everything, about all the possible NLP variations. But now we want to start, bridging the gap. And I know we have a lot of large language models talks related at this our Autumn Data Conference today as well. So just a small disclaimer, I wouldn't be going into like RAG details much or at all. I'm focusing specifically on the hybrid search approaches, like something which is still a modern search implementation where we're trying to combine the vector similarity, the classical filtering, the classical ways of searching, and it's still not going away. I would say, like, because a question answering from RAG is definitely there. It's definitely gaining the popularity. People asking questions, getting answers. EPAMs, we've been proud that EPAMs was doing these question answering projects even before, let's say, hype of the ChatGPT. I remember in the conference, EPAMs conference, a couple of years ago, where we actually trained and use some of the embeddings actually popular at this time. I don't remember were those embeddings. So we could answer some questions about EPAM based on some of the knowledge base. It was like, I think up to 3 years ago. So yeah, so speaking of those disclaimers, let's start getting this bridge over and what's this hybrid approach is, right? Like you could say, hey, I just don't need it. I just could ask the question to some sort of knowledge base, to the knowledge information. But in fact, I would a little bit disagree with this one, right? Because very often we have a situation where I want to find a restaurant that I might like, right? According to my profile, according to my taste, according to my cravings, maybe, and this could imply vector search for better understanding of nuances, right? Because if I mentioned maybe lasagna, this implies that I like also Italian food. But also, very importantly, I want to make sure this is a restaurant that located maybe within 10 miles out from my location, and it's a low to medium price. And this is definitely a combination where we have a vector search, some of the interests with some of the more natural language requests, like what I'm craving of, as well as some more strict limitation, because I really don't want to find the best Italian restaurants in the world, and for example in the UK where I'm located. I wanted something still reasonably and probably located close to me. None of the vector part probably could do this without a strong like redoing of the stuff. And you could think about some other approaches, maybe not in the let's say places of interest search, but you could think about find me in images of a cat, and you could use a vector search for this one as well, but this should be uploaded last week, so we could use the filter. Or if you want to do some sort of fraud detection, we could discuss how what are the user behaviors, for example, and this is so-called bad. And for example, you want to compare this is a new user account or fresh user account. So there are a couple of different options how traditional approach and modern vector search approach could be also combined together. And yeah, we're gonna move on into actual implementations and challenges, because while those large language models are, introducing really excitement advancement, I really don't want to underestimate those. We really want to make sure that those are put in the proper context, especially used for information retrieval. So they often need to have specific functions, specific type of behavior, faceting, and whatnot, filtering, geo search. You could think about different possible challenges here. But more specifically, we're going to also talk about even challenges like that come in before we even do any type of search, right? Because often these days I found that we keep talking about data quality, especially like in parsing, pre-processing, extraction of the data, but it's really, really, really critical, really crucial, because if not done properly, if those passages or chunks would be created improperly, we're gonna really be getting worse search performance than expected. Another challenges that often appears in the hybrid search or just in general in search implementations is actually relevancy tuning, right? So combining those different multi-factors into one score, into one ranking list is very often difficult, especially if add on top that very often when we worked with the customers with the different projects, there is often lack of like golden data sets or judgments list, right? Like nobody really wants to spend months on creating specific golden data set where you could have like a questions or queries and all of the judgments list and with the relevant documents, with the positions of the relevant documents, so you could use them later for calculating some metrics like NDCG or MIP or even F1 score if you're going to talk about some simple metrics. We want to make sure that the models we selecting, right? There is a variety of the embeddings models that exist out there, but we want to make sure we understand and kind of test and maybe even validate those things, especially maybe in a specialized domain like a medicine, healthcare, for example. You could think about other implications of domains as well. So let's dive deep into actual challenges. Once again, want to rely that this is example of real project that EPAM was working on. I was helping with the teams as well. So let's take a look at some of the setups. And this is basically a high-level architecture of one of the projects where we were implementing hybrid search. And I'm not going to go like through all of the slides through all of the architecture here. But what is really important is we have variety of the different data sources. So we're talking about like unstructured and semi-structured data. So like PowerPoints, PDFs, Word documents. We're talking about different types of the medical databases that are available online and available globally. We're even talking about some more like semi-structured or like almost structured content coming from Excel. And we see that one of the crucial parts that I wanted to touch here is actually data pre-processing, because that's really paramount to like how the quality of your text extraction, especially coming from those files, especially coming from unknown type of formats, it's really challenging. We want to make sure, since it's a medical domain, we want to make sure to go through the compliances check, for example. So we want to make sure that none of the actual patients' names, for example, could be mentioned, or any type of names, to be honest, right? Because a lot of different regulations like GDPR or HIPAA compliance are in place. We also want to use some of the machine learning classical, let's say, NLP approaches, like named entity extraction, as well as vectorizations and embeddings creation. And actively, we're using OpenSearch as a hybrid search engine in this case, where we're combining traditional searches plus vector similarity searches. And very important is that since there's so much variety of the data, this analytical platform that we're creating should be able to answer questions looking from the different perspective, right? So maybe from the perspective of different departments or different parts of organization. Because if you could ask, questions like, what is important to healthcare providers, for example, you could very often see that for them, a combination of cost effectiveness treatments or medicines is very important, right? Because they are, if you're talking about US, very often insurance-based, money-based. This is a business for them, right? While on the other side, if you're talking about patients, for example, actual patients, for them, probably money might be important, might be second or first priority to some of them, but to a lot of them, priority would be a quality of life, for example, or that the treatment is helping them and don't have maybe side effects. So you see how answers and living like insights could be different based on the different data sets, on the different kind of personas that you took a look at. And while dealing with this type of data, we were even finding very funny examples where there could be like one slide, there could be like two contradicting opinions, and here I'm just recreating the slides, so I don't use any specific client information or whatnot. But just to nature, it's very similar structure where there is two contradicting opinions coming from one side and from the other. In this case, one opinion on the left side is saying, hey, I believe that LLMs, actually improve the accuracy of language understandings. While opinion on the right says, actually, yeah, it still struggles with some sort of accuracy. And this was the real data that we were working with. And parsing it by itself, maybe not that challenging. You could get the text out of it if you're not talking OCR, even if you're talking OCR, to be honest. But how to make sure that this structure kind of preserved and we keep in those opinions as a separate chunks or as a separate parts of the documents even. And before we get started, I just tried, the new features of the ChatGPT that was released actually last week, right? Like OpenAI, after OpenAI Dev Day, in this case. So I used this slide, the previous slide, actually. I uploaded it into ChatGPT and asked questions. I did a little bit played with the prompt, to be honest. So it's not going to be explained to me what's there in general. But I'd rather ask questions like, how, are LLMs providing accurate answers, yes or no? And ChatGPT thinks that no, they do not. So basically, what's happening is probably weight of the answer on the right is overtaken in this case, which is not maybe the worst answer that you could possibly get, but still something I would ideally like to improve. There's probably something to do with the parsing or my prompts, to be honest. But what actually we did in the project, since all this data is a private data, we're not really relying on any type of public available APIs and whatnot. We were actually one of our team members, and I just posted a really cool GitHub link to this GitHub repo. Please check it out. These guys deserve some attention. What we did is actually fine-tuned YOLO v5 model actually in order to make it detecting those object and text detection, right? So basically we used it and fine-tuned it on the open data to increase the precision for detecting exactly complicated passages like this. And you could see I just posted example of how this computer vision model works. So it clearly separates those different passages, which we could later extract different separately and store them separately and create embeddings separately. So to provide different proper retrieval in this case. Very cool stuff once again. So that was about parsing, and to be honest, there was a lot about more examples of the data. I could just talk for 2 hours just explaining what are those examples. But let's take a look into how we're going to combine and how we were combining this multi-parameter scoring. So once again, what's happening is very often we have traditional filtering capabilities, traditional BM25, TF-IDF and whatnot, similarity scores. So they represent some similarity to the query. They could be a geo-point query, for example, as well, like geo-distance query as well as vector similarity search. So like if we have an n-dimensional space, there's some vectors that are out there, and we want to have, let's say, cosine similarity or dot product between those vectors. So there is like two different scores. So how to make them, how to combine them together. And to be honest, this is really not a new problem that appears just from the LLM perspective. That was out there for really long time. And some of the classical approaches, but bad approaches, to be honest, is to have some sort of a boosting. One of the possible options is to do the boosting. So we have a combinations of, let's say, some boost to the classical score versus not boosting the vector score, or it could be vice versa, to be honest, really. Or it could have even different coefficients. So the idea is that we see the importance of one scoring over another, and definitely you could immediately spot out that this is not gonna work out really well for everybody, not gonna work out for every scenario. So this is not really something I would recommend. Another really tempting idea is to think, hey, I'm gonna normalize the score for the classical retrieval, and I'm gonna normalize the score for the vector retrieval, and I'm just gonna use some coefficient once again and sum them. This is not great idea either as well, especially since normalizing and to have like this, let's say, percentages, like what does 100% means? Does it mean that's entirely accurate to what the user asking? Probably not. It just means that it's just the top scorings that appears out there. The scorings out of the classical information retrieval is so much complicated that it's not really even meaning much. So another approaches would be like to do maybe sometimes some sort of constant scoring, and you could replace basically those parts of the equation with a more expected and constant score. So for example, matching score from the classic value is just 1, or let's say 2, while vector similarity might be represented as a cosine similarity, let's say from -1 to 1, where we would normalize it, let's say, from 0 to 2 or from 0 to 1. This is a little bit of better approach, but really nice way to do this is actually going into RRF, so reciprocal rank fusion, actually. So combining not the scores but the ranks. So this is really a fun part of it, where we just combine the ranks of classic retrieval. So let's say if the document is number 4 in classic retrieval and number 2 in ranking, we know how to calculate this new combined fused even score, not combined but fused score. Using those fused score, we could provide much more accurate ranking position, and this is definitely a really cool technique to be used. And I'm just going to show you example of this reciprocal rank fusion actually methods that are available in Elasticsearch, for example. And don't get me wrong, it's not available just in Elastic. It's available in tools like Azure Cognitive Search. It's available in Vespa. It's available in VIA8 vector database, for example. Very all cool, hybrid engines to be used. So here, looking into Elasticsearch, and this is a screenshot of actual queries to the Elasticsearch. I'm using here only 3-dimension dense vector, just for simplicity. And I've created this index. I've indexed the documents, different types of documents, for example, t-shirts, let's say Adidas t-shirt, and like awesome whatever t-shirt, with some fake embeddings, to be honest. And how I could combine it all together, actually. So I could combine this really in what to me is a hybrid search in a nutshell. I'm combining some text with what users are searching for. I'm combining, let's say, a KNN, K nearest neighbors approach to find the most similar to this query vector based on the embeddings. And I'm using the reciprocal rank fusion actually to combine them all together. what's add even more cherry on top of it, I could still use my aggregations and faceting, so to provide, let's say, distribution of the pricing, let's say, across the products. So this is much more of an e-commerce domain. Okay, this was cool, but also let's take a look how we're going to retrieve the models. How we're going to evaluate the models, right? All those retrieval models is out there, embeddings out there. How are we going to compare them if you're not going to have any judgment list? One of the approaches we used on one of the projects is actually to have two sets of similar questions. So let's say question 1 in dataset 1 and question 1 in dataset 2 is kind of similar question, but a little bit paraphrased, a little bit use maybe different linguistics, maybe some typos and whatnot. And we want to calculate the cosine similarity for the different models that we have out there. And we could provide the heat maps, actually heat maps that exist out there. And I could just give you an idea of like what you want to take a look at. And once again, this is something where you don't have historical data or golden data set that you could measure quality upon on. So in this case, one of the like classical intuition is that your diagonal should be really kind of close to 1 as much as possible, because this is exactly the same questions but just paraphrased. So like 0 here and 0 here is exactly very similar, and according to this model, it's actually quite similar question. So it says it's 0.91 in this case. The rest of it, since it's different questions, we're not entirely sure what you should expect, more like orangish kind of thing, or let's say more darker thing. So it's about like how similar those questions are. But what I can say for sure, you don't want to have a picture like this for your embeddings, for example, because this is clearly, first of all, a very inaccurate diagonal, right? Like some part of it is more close to 1, some part of it is not really, and these lines are really concerning lines because they're very low similarity, and that looks like kind of like outliers. So maybe it's something to do with embeddings, with the quality of embeddings. So definitely wouldn't use an embeddings model like this one. I'm not sure what I'm going to choose between those two. It's subject to interpretation as often. Maybe something to show to the product owners and whatnot. Some of the subject matter expert. Let's speed up a little bit. I know we're running a little bit out of time.
Yeah. We just have a couple of minutes left, unfortunately, Cass. There are also a couple of questions, but let's see if we have time to address them.
Let's try to feed the content, because there is a cool amount of content, at least I think so.
Yeah, you can talk forever about this. Yes.
Yeah, very quickly, another part of the embedding. So we were talking spell checkings, right? So let's maybe spell checking would be the last part that we're going to touch on. Very often, LLMs implies that we should be relying much on the spell checking. It's not an issue anymore. LLMs could understand those, but is it really so? Let's check it out. So once again, in this case, we have a data set of up to a little bit more than 10 words. In practice, you want to have a bigger list, of course, with the words that is important to your domain. So in this case, we're using the biomedical domain. And we're using some of the open source models, open source embeddings models. If you don't know these names and you think like maybe that's just bad models or something, this is actually one of the top models in the embeddings benchmark, MTEB, that is available in the Wild West, in the wild internet, actually. So this is actually one of the top embeddings open source models that are available out there. And what we're gonna do, actually, we're gonna create a variation of misspelling words from this list of the words, and we're just gonna once again combine the cosine similarity. So we're gonna go through all of them and combine the similarity and get another heat map. I imagine you all like heat maps. Now what we can see here, so we see that, I'm going to explain what this graph means. So this is the x-axis is the different models, so 4 models that we're testing, and this is the pairs. So this is the word thrombosis, and we have a misspelled version of this thrombosis word. So and we try to compare like how much model understand this one letter difference, like one misspelling difference. And in this case, we see that some of the models, like first one and third one, might not really understand they are pretty close. So for example, one misspelling in patienter, is actually leading to very low similarity, similar like to chronic, for example, or fatigue, or treatment. That's very interesting, once again, to interpretation. So I would say that those models, the second and the fourth model, are more tolerant towards misspelling. So definitely something you could check it out with your embeddings. And of course, you could do exactly the same with any type of embedding, such as OpenAI embeddings as well. Some of the LLMs, approaches could be used in data quality use case as well. And very quickly, not going to be explaining the graphics, but for each of the products in your e-commerce catalog, for example, you could calculate and classify, even using LLM, for example, which category it should be attributed to. So in this case, one of the scenario is that you could identify misattributed products. And last, actually, I'm just skip a couple of slides, but that's fine. That shouldn't be much of a deal. Another exploratory analysis that we found pretty cool. In order to find the mistakes in data, in chunking, having even wrong, let's say, files or data sets, instead of finding most similar answer or most similar vectors, take a look at the least similar answers. And this is what happens to us when we were looking into medical domain presentations, and actually found a big chunk of trip-related and tourist-related documents, which, I don't know, ended up maybe by mistake in the data set, and we found them using like the least similar similarity. Basically, in this case, we were finding that there is like documents which are not really related. So which is once again cool. Last, before we go into question answers, this talk wouldn't be possible without at least help of a couple of people, and I want to mention them specifically on the slide here. Ekaterina, Andrea, super cool colleagues to work with, helped me greatly preparing for this presentation. I couldn't do it without them. And the list is a link to my GitHub profile, where we have all the code, all of the examples of the code, including heat maps, including all of these validations that you could run yourself, check yourself. So please check it out. Done. Now it's time for questions.
Great. Great talk, Kos. Thanks. I think this is a very deep dive in the LLM search. We have almost no time for the questions left, but I think we can address one. So, Kos, what's your opinion on the best approach for fuzzy search, messy human input data? Do standard normalization approaches are good enough? Before stream matching using Levenshtein, is there a possibility to use LLM for entity for normalization or entity extraction? What do you think about that?
So definitely, as I was shown, like in this example of misspellings, right? Like some models are better for misspelling than the other. So this is definitely to double check on this one. I think LLMs, as they capturing more and more and reading a lot of text, right? Like those large language models these days, they read so many books, you could say so, right? No human would be able to read in the whole entire life. So they know a lot of these context nuances, even misspellings for sure. So they would be naturally very good in dealing with this one. But as I showed you in the heat map, some are better than the others. So definitely check out on this one. Levenshtein distance still stays, I think, to some extent. The challenge is that Levenshtein distance of 1 is like change of 1 character. Pretty straightforward, helps a lot. Levenshtein distance of 2 is like you could almost turn bread into beer, almost like, right, entirely, but just by changing a couple of letters, and the meaning changing dramatically. So I think combinations of most common misspellings, like maybe dictionary or more traditional Levenshtein distance plus LLMs, I think would be paramount in dealing with those challenges.
Okay, good. Okay, thank you very much. That was Konstantin Perikov, our head of search competency in EPAM's data practice. Stay tuned, and we will continue with other talks on engineering stream, and please don't hesitate to check out other streams. Thank you, Kos. Thank you all for viewing this fascinating talk.
Thank you. Cheers.
Generative AI. We bring production-ready solutions to expedite clients in GenAI transformation. We have GenAI Innovation Hub, ready-to-use POC and accelerators and cross-functional team of experts to support our clients. Generative AI Virtual Tutor Assistant. EPAM Virtual Tutor is an GenAI-powered L&D accelerator designed to provide a personalized learning experience to various groups of students via quizzes, flashcards, Socratic learning. Personalized Meta-Human Assistant. Virtual Assistant is a question and answer solution powered by LLM and conversational interfaces for a broad spectrum of tasks supported. Unlock the boundless potential of your business together with us. Contact us on epam.com. Computer Vision Solution is an end-to-end CV-powered products development from an idea to productization with diverse list of use cases. EPAM is ready to develop the variety of solutions from virtual try-on which redefines digital and retail experiences and customer behaviors. Two Computer Vision-powered AI Merchandiser Accelerator for CPG leaders to optimize store-level sales performance and enhance operational efficiency, as well as an advanced recommendation system for the fashion industry that takes into account both traditional information about customer preferences and the customer's sense of fashion by analyzing the visuals of products that arouse consumer interest. Unlock the boundless potential of your business together with us. Contact us on epam.com.
Fake news, misleading information, AI-generated images. How can we navigate ourselves in this era of post-truths? A group of engineers from EPAM's Operational Intelligence practice, Olena, Khomuliak, Oleh, Pelekh, and Ustyianovych, will talk about how we can cut through the noise. We'll dive deeper in the latest approaches, how we can detect fake content in the real time. Please, Olena, Oleh, Taras, join us.
Okay.
Good to see you all. Good to see you. How are you?
Yeah, thanks to see you too. Doing great.
That's great. That's great. Okay, I'm very looking forward to you talk about misleading information detection. And for our viewers, please don't forget that you can post questions to our speakers in the comments on our YouTube stream and in the QA session on the VR community platform. The floor is yours, guys.
All right. Thank you for the introduction. I think we can get started. So, yeah, this is a topic, cutting through the noise, how to detect misleading content in real time. And here we are, three speakers from the operational intelligence practice at EPAM, where we mainly work with real-time monitoring and solutions like that. So who we are, so as you already know, we are from operational intelligence practice, and 1.5 years ago, we got interested in the misleading content detection problem. We participated in the hackathon, developed some useful products, and managed to collaborate with different organizations, institutions, companies. And today we would like to share not just this experience, but also the engineering path we completed and sort of what solution we come up to handle this misleading content problem. So let's get started. I hope you're gonna enjoy this talk because first of all, it's very interesting. Second, I'm not afraid to say a little bit controversial. And third, it's at the same time very crucial. And here is the agenda, what we're gonna cover today. First of all, I'm gonna guide you through the problem statement. Then we have a project setup. Olena is gonna talk about customer needs and basically implemented solutions are going to be covered by me and Oleh. There are two solutions that we managed to implement. And at the end, I'm going to share what results we obtained, what might be the future trends in this problem. And of course, we're going to have some space for Q&A. So the problem statement, as you know, 21st century, the internet is available almost at any place on the earth, and information is shared basically in a matter of seconds. And as we know, there are many techniques how we can reach the target audience. But of course, despite the fact that a lot of information is available, not all pieces of information are useful. Some of them might be harmful and specifically designed to mislead people. And my question would be like, what the consumption of such content might cause? And on the next slide, we're gonna figure this out. So you might think, but overall, first of all, information became a weapon. We have destruction of communities, no critical thinking, and actually the information space doesn't get trustworthy and reliable, and we don't know what might be the best source to consume really reliable information from. And you might be questioning, like, wasn't nothing done about this problem? Actually, I will tell you there were plenty of researches done, and the thing is, there is always most of the pieces of research are very limited and very specific, and there is no generic solution for detecting misleading content. Yes, there are fact-checking tools, but they're expensive. They always or almost always require human interaction, human in the loop. And the next thing is that despite having a cool research project, despite having a cool solution, you still have to put it in someone's hands who has the authority, the power to moderate the content. And I think that's what research project lacks in real life, and what we try to address using our engineering expertise in monitoring and machine learning. So now I'm going to show you some cool examples of how propaganda spread and misleading content spread happened in the internet. So here you can see the red dots represent propaganda about vaccination and how it spreads. The network diagram basically shows it to you. Next thing is echo chambers. So basically this is an environment, as you can see here, where people consume only such pieces of information they agree with. So this is a biased environment, and it creates sort of, I would say, addiction, and getting out of such environments might be tough because people, the users are already biased, and it might be full of biased content, misleading content related to specific viewpoint and not others. So there is like a huge pie of this problem that we can research, and we decided to focus on the Russian aggression against Ukraine because the problem is one, but there are many viewpoints supporting different sides, having different views, and actually we wanted to tackle this specific problem and understand, first of all, what are the patterns of this content. Second, categorize large number of text pieces into meaningful topics. And our third task was to classify towards what viewpoint a specific document is biased. And we managed to accomplish this using NLP techniques and machine learning. We did not apply any transformers, generative AI, because like you're gonna know later why, but we still think that there is space for such applications, and they are really valuable. So I want to share with you this quote. What is it about actually? That in time of crisis, you can see either opportunity or you can see a crisis. And we saw opportunity that we can contribute to the scientific developments and also develop a robust tool capable of assisting with misleading content detection and understanding various patterns in real time. So what opportunities specifically we saw? First of all, it's the rise of AI, of machine learning, capable of processing huge amounts of text. Next thing is we were dealing and we are dealing with low resource languages like Slovak languages, for instance. And as you know, there are not so many transformers or even vocabularies that could deal well with these languages. So we decided that we could do something to improve this situation. Also, there is many information related to the topic we researched available online. It's a useful contribution, and we managed to successfully deliver our solution to real clients. And yeah, today we're gonna actually talk about this as well. So what's the project setup? First of all, I'm gonna start with team and contribution. So we have EPAM core team, people mainly from operational intelligence practice who supported and made their contribution as volunteers, and which later turned on into an accelerator. We contributed with Splunk, with Technical University of Munich, University of Alberta, and Lviv Polytechnic. So these researchers, these companies agreed to support this. And what we managed to get out of this, you're gonna learn today. So we got some computer resource from some technical support and expertise from University of Alberta. Splunk provided us with 1 year license to ingest 10 gigabytes of data daily. People at EPAM, our colleagues at EPAM, were also willing to get their hands dirty with analyzing the data. And as you can see, Lviv Polytechnic academic staff, Technical University of Munich academic staff agreed also to work on model development, on data collection. And at the end, we also got a mentor from EPAM who helped us to turn this research idea into an accelerator where engineers could practice their skills with solving real-world machine learning problems. So what we've gotten so far, we have powerful computer resources, experts with domain knowledge, decent set of solutions, and many more. But throughout the journey, we managed to implement a much more better version of the accelerator we have so far. And yeah, basically here I want to show you how was the solution designed initially. So it's pretty straightforward. Data was collected through APIs. Then we did some data pre-processing, which included transformation, feature engineering, text analytics. We applied mainly open source tools like GenSim, NLTK, XGBoost, and MLflow to train the models, track experiments, pre-process the data, and all the results were sent to Splunk, where we had basically, as you can see, five different tiers: collection, forwarding, indexing, and search, data storage tier, and knowledge objects tier. And knowledge objects tier, that's where we have 5 dashboards, and each of these dashboard was showing an end-to-end journey from model training to text analytics and inference results, and assisted us throughout all this path. So, but you might question what's wrong with this solution? And I would tell you that first of all, Splunk is the opposite of cheap. It's very expensive, and if you want to deliver an open source solution or something less expensive than proprietary fact checking tools, then you should probably move out from Splunk, depending on your customers. And that's actually what Olena is going to talk about. So data sources, it's mainly social media, instant messaging platforms. We also got some piece of data from the stakeholders, which we cannot identify. And here I'm going to show you how the data looks like from specific social media. So it's JSON mainly, but what's special about this JSON, it has many useful attributes, not just the text, but also number of likes, number of shares, comments, geolocation, and we can also design like network diagrams, cluster the users based on the activity, and of course we can use the text to extract named entities hash text and analyze how the hash text usage changed over time, what was more popular, what was less popular. And yeah, the information you see was really rich. And here's basically some diagram showing everything you can do with the data we had. It's like, first of all, input data preprocessing, text preprocessing are pretty common for almost any NLP project. And you might be interested in knowledge discovery. And it might include semantic analysis, user reaction, user engagement analysis, time series. We also did association rules mining for hashtags usage, topic modeling, network clustering, classification. So there are many more things you can do basically, but this is the most crucial ones and what we did. And yeah, at the end we got a real client, and that's what triggered us to switch from Splunk. And my colleague Olena is gonna share with you about the customer needs and why we switched from Splunk to more open source things. So Olena, I give you the word. Please go ahead.
Yes, thank you, Taras. Hi, everyone. Yeah, I'm Olena, as you may know, and I've been working with customer needs and requirements. You have just been acknowledged with the problem statement and have an idea of what it is and the needs it addresses. But for a better understanding of all values and needs and for the improvement of those solutions, a user persona was created based on an analysis of our key stakeholders. Two user personas were defined, one representing a software engineer who works directly with the product, using these ML models to process text and configure it based on requirements or needs. And the other persona represents an analyst, data analyst, or security analyst who works on finding patterns, analyzing process data, and drawing conclusions based on it. Both personas aim to protect data and information through technology, but have different specific needs and frustration based on their roles. To summarize what they were looking for, I want to highlight key points. Seamless integration with intelligence systems, enhanced data management and information sharing, not expensive tool to automate process and stay informed, and the ability to act decisively against evolving digital threats. Next slide, please. So following the definition of the user personas, a value proposition map was created to align the client needs with the provided solution. In essence, our customers sought an affordable, fast, and efficient tool for detecting destructive content that could handle large-scale data. Thus, our goal was to enhance our existing offerings and provide them with an open source and adaptable tool for automated topic modeling. This tool would integrate with existing intelligence system and adapt to counteract propaganda in the age of misinformation. We aim to closely align with the tool with the needs and goals of our customers, covering everything they were looking for and providing the relief they sought. Next slide. And so we would like to be unique, but of course such solutions already exist. Therefore, I want to briefly familiarize you with those existing solutions that are more similar to what we have developed. So here we have Mulfar, Graphica, and Mantis Analytics. They are all different for sure, but they are all united by the fact that they work with large-scale data, use machine learning technologies, NLP and ELM models to extract insights from social media, news articles, and other online sources, and for fast and effective analysis. All three tools are designed for identifying patterns, trends, and anomalies in data. They have deep data analysis and investigation of disinformation content on the web. So while there is some overlap in features, each solution has its own unique purpose. These solutions offer a range of other features, but the ones I've highlighted are the ones that most closely align with our tool. So that's all from my side. Thank you, and I pass my word to Oleh.
Thanks, Olena. So, hello everyone, I'm Oleh, and I'm thrilled to be here today to talk to you about an exciting and powerful tool in the world of data analysis. It's automated topic modeling. So in a couple of the next minutes, we'll explore both its advantages and, of course, challenges it presents. Next slide, please. Our team developed an automatic topic modeling approach that effortlessly sifts through the data and identifying underlying topics and trends. So let's start from its benefits. So first and foremost, like this automatic topic modeling is revolutionizing the way we extract insights from vast data sets. One of its standout features is the use of LDA. So this is not only speed up the analysis process for us, but it also makes it more accessible for a wide range of applications. And additionally, automated topic modeling provides us with meaningful visualizations. So this aids in comprehension and also enhances the interpretability of the results. Furthermore, it worth nothing that this approach is highly suitable for a local deployment. So, however, like any other tool, this topic modeling solution comes with its sets of challenges that we must navigate. So one significant challenge is dealing with dynamic data. So in a rapidly changing environment, the model needs to adapt. This dynamic nature can pose complexities in maintaining accurate results. Another one is perplexity metric. Often it's considered as a reliable measure, but it can be tricky. So sometimes, as we aim for more meaningful insights, this metric might go down, and interpreting its implications require a nuanced understanding. And of course, our journey doesn't end with just initial model. So continuous efforts in model training are crucial to ensure the relevance and accuracy of our analysis. And another challenge is determining the optimal number of topics to choose. So now let's shift our focus to how we tackle the challenges outlined just now. So can we go to the next slide, please? Okay, so on the screen, you see a snapshot of our solution. This is a Splunk dashboard, and it has become an integral part of our strategy to navigate the complexities of dynamic data. Thanks to this dashboard, we can keep a watchful eye on our ML flows and experiments and runs. So this enhances our understanding of the model performance and provides valuable insights for our continuous improvement. And of course, every model encounters performance issues at some point. So this dashboard highlights performance issue early so that we can fine-tune our models in no time. So another challenge is choosing the optimal number of topics. This challenge is met with just simple visualization on this dashboard. So every time we had to check our dashboard in order to select the optimal number of topics. So this is not a best approach, of course. So we came up with a solution for automatic topic modeling. Next slide, please. Yeah. So our algorithm for selecting the optimal number of topics is novel, and it deploys individual approach for each metric. So as an input, we have a data frame with two columns. The first one is a topic number, and the second is a corresponding metric. And as an output, we have optimal number of topics, which is based on a corresponding metric. So in a couple of words, how it works. So the first one, it starts by calculating discrete difference in coherence score, then it's identifying local maxima. After it's selecting the optimal number of topics with the highest coherence score. Here you can see code snippet on the screen, and it's in Python. So let's move next to the optimal perplexity value. So this value is selected on a slightly different way. For that, we use a Python neat package. So with this, we find elbows on the perplexity measurements by calling a knee locator class with the parameters you can see on the left side of the screen. So as an output, the algorithm returns the lowest perplexity with its corresponding topic numbers. And considering the next algorithm, it's UMass coherence value. So the algorithm identifies the three values nearest to 0, and the corresponding topic number is selected. So the algorithm automatically opts for the one with the perplexity value which is closest to 0. So next slide, please. So on the right side of the screen, you can see visual representation of both of three algorithms that we discussed just now. So as you're probably already aware, we don't settle just for one metric. Instead, we explore multiple metrics to discover optima for each. So once we identified local optima for each metric, we then have the luxury of choice. We can pick the best value from these findings for each metric, and it allows us to prioritize based on the specific needs. So whether it's a value recommended by CV coherence score or a combination of metrics, our approach ensures that we are making informed decisions. So next slide, please. Topic modeling. Topic modeling is at the heart of our approach, of course, and is powered by the LDA algorithm. On the right, you'll find a visual representation that includes topics allocated on a Cartesian plot, and the top 30 keywords terms, both overall and per topic. This interactive visualization is derived from approximately 6,000 documents, specifically Institute Study of War daily reports. So for individual document, our model provides the top and most likely topics along with their respective probabilities. So what we've just discussed is only a part of a broader narrative. And my colleague Taras is here to provide an additional layer to our understanding. So without further ado, Taras, over to you.
All right. Yeah, thank you, Oleh. Thank you, Olena, for covering your parts. And I expect this provided more clarity to why we selected the solutions we selected and what we managed to get out of them. So the second part is a bias detection model that also was done using means of machine learning and NLP. And it cooperates, I would say, with the previous solution with the topic modeling. And now, let me introduce to you how it was developed. So, the main goal is to predict, to classify towards viewpoint a specific input message is biased. Is it viewpoint 1 or viewpoint 2, whatever? And ingredients are pretty common: data set, compute resources, and you just need some tools, models, libraries to process your text. Of course, there are challenges. The main challenge was language is low resource. So, for instance, with English language, you can do many, many interesting things, and there are already probably pre-trained models, and you might not need to play a lot around the text data. For our case, it wasn't. So we had to we really struggled to find the optimal set of models and solutions to work with. Second thing is text was ambiguous. It was noisy and sometimes even irrelevant. However, I think if we had a little bit of noise, it's a good thing because it prevents us from overfitting. And conventional methods like back of words, doc2vec, for2vec don't work the way we expected. Actually, they work, but the performance is very poor. It's like 75% of accuracy when we use this models, this vectorization techniques, and it's not what we were looking for. We weren't pleased with that. So what's the data set we've collected? It contains like almost, I would say, more than 250,000 text entities from instant messaging platform Telegram. And the dataset was pretty much balanced. You see 55% for viewpoint 1 sources and 44% for viewpoint 2 channels. And most of them are news and reports. There were also some messages from blogs, from reviews, and text length varies from 200 to 600 characters per the channel. So here you can see some descriptive statistics, and you see mostly like text lengths or number of characters, and tokens lengths, number of tokens. You see it's mainly 25 on the mean. Median is pretty close to it, and of course there are outliers. And later on, we identified where the outliers came from what specific channels, and is it a bad thing or it's a good thing? Yeah, we also worked on sentiment analysis. If you don't recall, it's like detecting neutral, negative, positive statement of the message. And as I said, we deal with low resource languages, and for instance, for Russian language, for Ukrainian language, libraries to accomplish this thing is pretty scarce. So we use a PyMorphy2 library. What's the trouble with PyMorphy2? It calculates sentiment for each word independently, and it does not consider context at all. And we were pretty much amazed in a negative way about the results, because most of the sentiment was pretty much negative. And it's obvious because the events we research are negative in its nature. And we also tried with LLMs. They performed much better, but also LLMs have some restrictions and constitutions. So therefore, using available ChatGPT, for instance, to classify the sentiments through chat is not a good option, actually. Here are some statistics. So as you can see how the sentiment changed for different viewpoints over time. And it's very interesting because you can correlate it with real world events. And currently, the last results were obtained on end of September 2023. And it's almost on the same level for both viewpoints. And on this histogram on the left, you can also see that it tends more towards negative rather than positive. Also, as you can see, viewpoint 2 sentiment is more positive, but the average one is still negative. So modeling entry point, we have binary classification problem. Dataset is pretty much balanced and diverse with a little bit of noise. We have the understanding of the subject matter. So if models does something inaccurate, we can easily fix it. And the initial goal is to validate the predictive performance. So the initial goal is not to develop 99.99% accurate model. It's just to validate whether we can do it, and the model can capture some relationship and some meaning. And during this modeling, we tried to be as much equal and unbiased as we could be, and therefore, I assume we obtained great results, which we're going to share with you later. Here is a workflow. So we receive some raw message. It's pre-processed, cleaned, lemmatized using Spacy. Then we applied fast text, manipulate with the vectors to have a document representation, and use XGBoost. And then we have the results outputted. We evaluated. The evaluation might include a subject matter expert. And then we can apply some techniques like even LDA or even text summarization to derive some patterns and get more meaning. So why fast text? Because there are a number of benefits, and the main benefit is if a particular word is not present in the training data set, but going to be present in production in new unseen documents, then fast text can still encode this word, whereas for2vec cannot, and you have to handle this somehow. And vector size for each word, we decided to make it 300. This is the same size as pre-trained fast text models, and our pre-trained fast text model actually had almost the same volume as the original developed by Facebook. And we use the GenSim implementation of fast text, but if you are curious about the original fast text implementation by Facebook, there is a possibility to not only vectorize your documents, but also to perform classification, and you don't have to use any third-party algorithms like XGBoost, decision trees, or whatever, which is pretty cool. Okay, so next thing was to create a document representation of the word vectors we obtained. Like you have to merge these word vectors of a particular document and have a document vectorized representation. So pretty much the workflow is very straightforward. So we have cleaned lemmatized sentences, then we vectorize them and obtain word vectors, and for each word in a particular document, we just sum their vectors up and divide by the total number of words. So which is sort of like an averaging word vectors of a document, and that's it. And at the end of the day, each document has also a vector size of 300. All right. Yeah, we decided to use XGBoost classifier, and because it's efficient, it's flexible, and we did some hyperparameters optimization for the AUX score. And as you can see, here is a confusion matrix. No, not confusion, it's correlation matrix, which shows what are the most crucial hyperparameters. And as you can see, max depth is one of them. So we have also booster type is crucial, and column sample by tree. That's cool. That's cool. We identified the most important hyperparameters, but at the same time, we should be aware that, for example, increasing max depth would lead to overfitting. Booster types, there are just 3 booster types available for XGBoost, so not that many, and it's already well known which one is the most important. And column sample by tree, it's also like if you play too much with it, you might get overfitting or underfitting, so you shall be careful. But still, this is useful information, I consider. And here are the results. So when we trained the XGBoost model with default hyperparameters, we got 91% of accuracy on the training set. I haven't checked on testing set, but definitely it was worse than with hyperparameters optimization. For the latter one, you see 98 accuracy train set and 91 on test set, which is pretty cool. And yeah, here you can see what was the hyperparameters that we shall optimize when dealing with such thing. Recently, I also got through a model on Hugging Face, which does similar thing, however, using transformers based on XML Roberto. And what's curious that their final performance, like accuracy, is 93%, and for us it's 91%. Whereas they use transformers and we use just XGBoost, which is pretty cool because we have a simple solution, which is not a black box, which is pretty explainable, lightweight, and it achieves almost the same performance but a little bit lower. And here I would like to share with you what might be the future work we can work on. And definitely it's application of deep neural network and large language models, and even designing some workflows using LangChain or some language model frameworks. It might be curious to use vector databases. And third item, you see, we lack natural data, and that's right, because we have only viewpoint 1 versus viewpoint 2. We don't have data from natural sources, and it might be also very curious to collect such data and train a model containing 3 labels. Of course, sentiment detection should be improved because using 5-morphial library, which was developed in 2015, is already out of date. And unfortunately, so far, I haven't encountered any reliable and accurate, up-to-date models to perform this task. And of course, we plan to contribute to development of language models with low-resource languages like Russian, Ukrainian, and probably some other. So now I would like to briefly share the conclusions. And as a conclusion, here is a question. So how the developed tools assist with misleading content detection and whatever we can improve? And the answer is pretty straightforward. So we use like on our real use case, how it helped. First of all, we use topic modeling to find out only what are the most relevant pieces of information we need. Because when you collect data on a specific keyword from social media, you might get many different text entities. And from our experience, only 30-40% of this data is relevant and to the subject matter you analyze. So on this 30-40% worth of data, we apply our classification model to find out towards what viewpoint it's biased. And then we have like two categories: viewpoint 1, viewpoint 2. We can summarize it. We can extract some keywords using text trunk, and basically make some conclusions about patterns and what can we do? How can we help the information environment, information space, to make it more trustworthy and reliable? So pretty much that's it on our solution. Any questions are welcome, and thank you for listening.
Yeah, thanks, Taras. Thanks, everyone. Thanks for the great job. I think no one can overestimate the importance of the job you're working on, especially in the current very complex environment and the rising of disinformation in the social media and conventional media. We have a couple of questions from the chat. So one of the question is purely technical. So what are the pros and cons of using fast text versus other transformer models like BERT, etc.? Why did you choose fast text?
Yeah, I think that's a good question. So, and the answer is going to be pretty straightforward. We decided to not dive into complex, such complex stuff like BERT and transformers. We decided to start with something small and gradually see what we're going to get. Because as I said, initially we started with back-of-forth and TF-IDF. Then we moved to DOC2VEC, Word2VEC. We weren't satisfied with the results. And some of our colleagues recommended us, hey, look into fast text. It's pretty cool. And I like the way it worked. It seemed to be pretty efficient. So, and as you know, yes, using transformers might be efficient, but it's also more expensive, compute expensive. And at that time, it was something we couldn't afford, or we just had didn't have enough time to accomplish this. But that's a great comment, and in the future, definitely we might experiment with transformers.
Okay, another one. So this is also important to consider, biases and mistakes. So either somehow some tools you have deployed to ensure the transparency of the decision making. So either is a, red stop button when when you see that something is not working right, and you're filtering out the real context, the real information. Is there some human, factor that can control the model? So do you have some tools for this?
Yeah, I think this is definitely very important because the topic is pretty sensitive. And since the developments, not just ours, but in this specific area, aren't mature enough, definitely human in the loop is required. We, as it was introduced earlier, even by Oleh, we have had Splunk dashboards that allowed us to find outliers and find find those entities that have very low probability of belonging to a specific viewpoint. And for instance, if we see that this specific topic or this specific category has very low probability and it decreases, the number of outliers increases, we were able to catch this on our Splunk dashboards. And it was a good indicator for us that we should retrain the model. So that's the only way we dealt with this problem. Yeah, thanks.
Okay, good. And another question, maybe addressing the complexity of environment you're working in. So how you address the vulnerabilities of LLMs to adversarial attacks? So do you have any stops, any prevention against the deliberate manipulation? So are there any cases when the context and content is deliberately introduced to mislead the model and to somehow break it? Did you have such situations, and do you have some solutions to prevent that?
Yeah, that's a great question as well. First of all, I should highlight I don't work with LLMs as a specific solution. Second, as I said, we try to be equal and unbiased in data collection. And of course, we are aware that such challenges exist. So therefore, while collecting the data, we did our best. But of course, when the solution is deployed on production, which we don't do, we are not the engineers who deploy. We just develop it on, I would say, on development stage. And there we don't receive any production data that could lead the model to biased conclusions. Thanks.
Okay, thank you very much. I think this is all from the Q&A chat that we have. I remind once more that you can post questions to our speakers on the We Are the Community platform into the Q&A session, and or put it in the comments on the YouTube channel. Thank you, Oleh. Thank you, Olena. Thank you, Taras, for a great presentation. I think this is a very important work. Remember, everyone, that we also have an ongoing quiz where you can get valuable prizes for participating in it. Please find the links in the description under the stream or in the QA channels. And also, please share posts about the conference with the hashtags. You also can get some fancy prizes for that. Thank you, guys. We'll pause for, let me see everyone again. If you are here still, wave to our viewers. Thank you guys very much for the job you're doing. Keep up the good job. And I hope this will have a great impact on everything which is going on. Thank you all. And we will pause for a couple of minutes, waiting for the next talk in our engineering stream. Please don't forget to check out other streams on vision and architecture and storytelling if you're interested in, and stay tuned. Thanks.
Thanks. Enjoy the conference. Bye.
Thank you, guys. Bye.
Thanks. Bye.
Hello, everyone, and welcome back to our engineering stream at EPAM's 2023 Data Conference. Securing today's cloud system is crucial as it protects essential data, it builds trust, and keeps digital services reliable. What are the techniques to secure a modern cloud data analytics platform? What are the best practices? And what we should be aware of? Securing Azure Databricks infrastructure with a click. This is a topic of our next talk on our engineering stream. Oleh Mykolaishyn, systems engineer from EPAM Systems, will present the EPAM Data Landing Zone Accelerator. Hello, Oleh. How are you today?
Hello, I'm fine. Thank you, Ivan. I'm so
Hey,
excited.
we have plenty of users, and I'm looking forward to a very crucial topic in our discussion.
Yeah.
Also, remind to all of you, please post questions to our Q&A channel on the We Are Community platform, or just put them in the comments on our live stream in YouTube. And please share info about our conference. I will not waste your time more and pass the floor to Oleh. Oleh, please.
Yeah, thank you. So, hello again. Today we will talk about EPAM Data Landing Zone Accelerator, a platform for infrastructure management within cloud and data for data-centric projects. So once again, my name is Oleh Mykolaishyn. I am a data DevOps at Data Practice Project, and I have been working on EPAM Data Landing Zone for more than a year. So first, we will do a brief introduction of platform capabilities, what offerings it has, and then we will review some architecture diagrams. And final section is dedicated to functionality demos, right? So I will outline this product for you based on 3 principles: why, what, and how. Starting with our why, the primary motivation behind this product is to accelerate projects right from their inception, specifically from an infrastructure perspective. While it is a common trend to design infrastructure provisioning mechanisms over and over for each new project using tools like Terraform, AWS CDK, even Azure Bicep, we offer an alternative approach. We recommend leveraging an existing EPAM-supported platform for your fresh new data project. In terms of what this product empowers organizations to swiftly set up their infrastructure on Azure, as well as other cloud platforms using Terraform. This rapid deployment ensures that workloads and applications are up and running in a minimal time. The product incorporates industry best practices and offers tools tailored for an effective data management. It ensures robust security measurements, comprehensive identity access management, and streamlined CI/CD processes, guaranteeing the security and compliance of the infrastructure in place. This product, organizations can provision the necessary infrastructure environment in as little as 30 minutes. This rapid setup enables immediate utilization of the platform, eliminating substantial wait times. Moreover, the foundation of this product is built upon industry-based, industry-recommended architectural practices, guaranteeing the infrastructure scalability, reliability, and performance. In simple terms, this is a production-ready accelerator that allows you to harness the features of, for example, Databricks, whilst at the same time meeting the requirements of your client, account provider, or support, and so forth. Following this brief introduction, I'd like to present a few diagrams and delve into further details. So first, let's draw a comparison between 2 approaches to infrastructure, the accelerated one and the more traditional, built from ground up. Common infrastructure requirements include scalable computing, a unified data management blueprint, identity access management, all managed by infrastructure as a code tool. The typical development timeline for such platform is from 3 to 4 months, involving a tech lead and several DevOps engineers. In contrast, the accelerated solution by EPAM requires just a single DevOps engineer. Over a span of 4 weeks, this engineer will acquaint themselves with our product. Furthermore, our engineer team will offer guidance for your project and ongoing support for the accelerator. In addition, we offer two packages for your consideration. The first one on the left essentially takes up to 4 weeks. During this period, we'll introduce the accelerator, guide the installation process, and ensure you are equipped with the latest version. The second package on the right includes ongoing development. Its standout feature is the ability to request specific functionalities. Building upon the accelerator's foundation, we can integrate cloud services not present in a standard accelerator version. Additionally, our team will offer ongoing support and guidance through any infrastructure processes. Several business use cases addressed include the delivery of cloud data platform POC, reducing time to market, migration from legacy stack to the cloud, and utilizing the accelerator as a complementary piece to your existing system. So today I will showcase the accelerator version for Azure. On slide, there is a diagram of services provided by the accelerator. At the bottom slide, you'll observe deployment layers, indicating which team operates within each layer. Currently, there are 4 separate Terraform deployments/layers. Progressing from left to right, we begin with the first layer called Azure DevOps Setup. Here, this layer configures the prerequisite Azure DevOps organization, project, provisions Terraform pipelines, creates service connections to subscription and repositories with our demonstration cases. After, we continue with deployment to the Azure subscription. Within the init hub layer, we establish a hub network, monitoring solutions, a self-hosted worker for Azure DevOps, and private connections. In case there is a requirement to host Databricks Unity Catalog Metastore or manage permissions within Databricks account, the init Databricks account layer could be configured. It is a separate layer where Databricks Unity Catalog features are managed. Finally, within the environment layer, a spoke is created, connecting to a hub network, serving as a location for all workload operations. This layer is entirely replicable, allowing for creation distinct environments like development stage, prod, and so on. Here you can provision Databricks workspace, environment-specific key vaults, storage accounts, Azure Data Factory, utilize private connections, and much more. Now let's discuss accelerators networking. Here we are using hub and spoke network topology. For reference, hub and spoke is a way of setting up network where there is a central network called hub and several other networks called spokes. But these spokes are connected directly to the hub using, for example, peerings. In our case, we are using network peerings. So on the left, there are our spoke networks. They are created by environment layer of accelerator. You can configure accelerator to forward all traffic from spokes to hub, and use custom DNS servers for these spoke networks. In the middle, there is a hub network managed by a init layer. Here you can see Azure Firewall instance that acts as DNS server and traffic forwarder for all spokes. This Azure Firewall instance has default Azure DNS server configured for query resolve. That's because all private endpoints within the whole accelerator infrastructure use this hub network to resolve, for example, their names using private DNS zones. These zones are linked to hub network, thus they are only seen from there. In case there is a multiple subscriptions utilizing accelerator, imagine first one manages Unity Catalog Metastore, and another one, for example, development subscription, wants to connect to it using Azure like private connections, private network. It is possible to create private endpoint to storage account where Databricks Metastore resides, like directly from another subscription. In that case, first subscription only hosts Metastore and organization data, and another subscription utilizes it using secure private connection. Okay, next slide. So after review of covered services and accelerator networking, I want to discuss accelerator release process. EPAM data landing zone consists of two parts. Both are developed by our team. These parts are Terraform modules and Terraform deployments. Terraform deployments are owned by EPAM, and they are hosted in internal GitLab repository. Meanwhile, Terraform modules are completely open source and could be accessed by anyone in public Terraform registry. If you want to contribute to our organization, for example, you want to host some Terraform module, feel free to contact me. To obtain version of Accelerator and try to use it by yourself, you could request access to repository with Accelerator releases. That's the one that is in GitLab and that is EPAM owned. Our team constantly releasing new Accelerator versions every few sprints, to be exact. Finally, when you have been granted access to Accelerator version, provision it to your cloud provider and you will feel the difference, and just check out our project. Now let's take a look at few case studies and blueprints following by demo presentations. Numerous EPAM internal projects have adopted EPAM Data Landing Zone Accelerator. Initially, many of these projects expressed a keen interest in efficiently setting up and managing Databricks platform in new environments. However, certain projects such as Data Practice Analytics, highlighted on the right side of the slide, have transitioned from their self-developed platform to our accelerator. For this team, we have developed custom features within the accelerator. And now this project creates all dashboards for data practice using this product. Another notable instance is a project called Data Cloud Migration on the bottom left. This one is dedicated to developing tools for on-premise to cloud data migration, entirely leveraging Accelerator. These instances are examples of successful Accelerator adoption in projects that required an immediate solution. Currently, we are pitching Accelerator to production projects after a successful series of deployments to multiple internal projects. So here is an illustration of how the Accelerator integrates with Databricks platform. On the left, we have the Azure subscription that manages Databricks Metastore. Within this subscription, we manage the Databricks Unity catalog and assign permissions across the entire Databricks account. To the right, there are two example projects. These serve as consumers of the Unity catalog Metastore, hosted by admin project. These projects connect to the Metastore via private endpoints, utilizing Azure Private Network. Users of the Metastore can only access catalogs designated to them by the administrative account, ensuring they cannot alter the permission structure. This approach maintains the integrity and identity access management and establishes a singular source of truth. So we are in our demo section. This demo is based around the deployment process, and I will show you this end-to-end process. So first of all, you have to have prerequisite Azure subscription, Azure DevOps organization, and service principles that would be used for deployments. So within your Azure DevOps organization, we create a new project. I'll call it Autumn Data Conference 2023. Once it's created, you clone the repository from our GitLab repo to your project. Here's our repository. I'll provide URL. You can authorize using your EPAM credentials if you have been granted access to this repository within the internal EPAM GitLab. And now I'm gonna import that's called in Azure DevOps or fork this repository. Create my own branch, code development. And now I have to set up my secrets that is going to be used during the deployment process. These secrets are called ICDA secrets. And basically, these secrets are our service principal credentials, target subscription, Azure tenant, and Azure DevOps credentials, and GitLab token for forking our GitLab repos with examples. You can also check out these examples within the GitLab. So when we are done with this, then we will edit each of our deployment layer. We'll start from the layer called Azure DevOps Setup. So within this, we provide our project name, the name of this repository where this code resides, and the region where we want to deploy. Commit. Then next layer. So within this layer, we are configuring exact Azure resources. We are providing allowed IP addresses to access infrastructure. In this example, I will use EPAM VPN network ranges. And I will provide the name of the security group that is going to be used within the Databricks network. This security group is already exists in my subscription. I just reuse it. Commit. Next layer, this is second layer. This layer provisions Databricks infrastructure, sets up Databricks account, creates Unity catalog and Metastore. I will provide my Databricks account ID. I also just check out default settings and add myself to the created Databricks account group. Then commit. And then we will configure our first working environment. It will be called default. First, I will provide network security groups. All right. Right, so we have prepared our code. Now we are starting to deploy. So you have to create only first pipeline manually. This is like the pipeline to set up Azure DevOps project. And this pipeline will create all like the subsequent pipelines and set up permissions within this project, deployment slots, and so on. So we are running this from our branch development. I'll speed up this section. So as you can see, now we have multiple pipelines, like the first folder with all Terraform deployment related pipelines. And the second, and the third is a worldwide importers demo. This is a sample database. And I will showcase this demo in next section. But we already deployed these pipelines with our first pipeline. So let's proceed to the first init hub layer. It will create our hub network with like private DNS zones, private endpoints. So it has been created. What we have in Azure. So our ADC 2023, we have Key Vault and we have private DNS zones with virtual networks. This is our hub network. So then we go to the second pipeline to set up Azure DevOps account and Unity catalog. This will create Metastore, like sample catalog, 2 groups with like default permissions. Right. So the same. We have our storage account with Metastore. We have our access connector that acts like a managed identity to access this Metastore from Databricks and Databricks related resources. So let's check out our Databricks account. We have new Metastore called primary ADC 2023 in West US, our target region. So then we will provide provision our environment called default. Here, in this dropdown, you can provide the name of your target environment that you want to deploy. So the default configuration is to create Databricks workspace, storage account, key vault. As you can see, it takes up to 8 minutes. So what we have here, we have our access connector, we have our key vault, storage account, environment-specific storage account, Databricks workspace for workloads. Here you can work on your notebooks, create your workflows and whatever. And also I have created the VM with SQL database that we will utilize in the next demo. Okay, right. So we have finished with our first. Let's go next. On second demo, I'd like to showcase very straightforward data migration case. We will ingest our raw data from SQL database that I mentioned previously to Databricks Unity catalog using Databricks workflows. Then we will create data products ready for consumption and analytics. From this ingest data, all would be done using Databricks and Databricks features. So let's proceed. So as I mentioned before, we have like this new pipelines called raw deploy and data product deploy release. What does it mean? Release, it's like two separate repositories called one called raw, another called data product, each like used for their own function. Raw is for ingestion, data product creates data products from ingested data. So first of all, you have to build this Python project, store it in Azure DevOps artifacts, and then we will deploy this wheel package with Notebook to our Databricks workspace. Let's first of all build these projects. We started building raw, and we will continue with data product. So our two projects built, and they're like notifying us with warning that new version is released. Let's see our Artifactory, what we have here. Yeah, here you can see this is like these two wheel projects, raw and data product. Now we will deploy with next pipeline this wheel package to the Databricks workspace and deploy the workflow and notebook. Right. So first we will deploy our raw. I will approve deployment. Nice. Then we will deploy our data product workflow. I grant permissions to the pipeline. So upon successful run, we will switch to Databricks workspace. Nice, we have both packages deployed. So let's check out our Databricks workspace. So we have two new workflows. The first, like the raw Microsoft WWI is used for ingestion, and data product Microsoft WWI used for creation of data products. And ingestion would be performed from this virtual machine with SQL Server using synthetic data. So we started our run. After some time, the data is ingested. Let's check out it in our Unity catalog. So we have like new schema called raw Microsoft WWI with multiple tables. These tables are ingested from database. And now I'll launch the second workflow that will create data products from these tables. Like after some time, up to 8 minutes. Yeah, right. We have another schema with tables. And this is like the dimensions and facts tables. You can build something from it, like some analytics. And I will show you our Power BI report that is going with this demo case. So you have this already created Power BI report that targets this data with some dashboards for analytics. Okay, right. This is our like data migration simple example. And in our final demo, let's imagine we are already using this accelerator within the organization. And client gives us a requirement to deploy a new environment, like completely new environment with specific requirements, with specific configuration. Like, for example, these requirements are, as mentioned, create new Databricks catalog, create a separate account group, like create brand new cluster with Spark 3.4 plus, and that it could be scaled up for up to 5 nodes, create Databricks SQL instance, some encryptions, private endpoints for Databricks, and create data factory with managed private endpoints. So let's check out this demo video. Now we will I'm sorry. So now we have directly configure our code. I have two pre-created TF4 files. The first one within the second layer where Databricks is configured, and another one, as you can see in project tree, is in environment layer. It is called dev, and I have written about the tasks that we were given, what we have to do and how to configure it. I'm sorry, some technical issues. So first of all, we will create Databricks account group. Databricks account group, and then we will create catalog. This catalog is called ADC 2023. So we will grant some privileges to this catalog. And as you can see, I have connected 2 groups, ADC 2023 with all privileges and our account users. Account users is like a default group within Databricks account. And everybody who is within this account could utilize this group and connect to some workspaces. So it's done. We are done with our second layer. Now we are going to our environment. I have some pre-created variables, but the one that we were given the task to do, we still have. Okay, we will kick off with connecting Databricks account group. Our brand new group ADC 2023 and account users are connected to this environment's workspace. I will prohibit account users from creating new clusters. And I will configure a new cluster. This cluster called ADC cluster, and using this user isolation data security mode. It is very important because only a single user and user isolation would be able to directly access Unity catalog. And also we were given max workers up to 5 and configured some permissions for account users that could restart this cluster and somehow manage it. Now we will proceed with our Databricks endpoint. I'm sorry, it's so you can see the final version of these TFRs. I'll just stop and explain you. Yeah, right. So at the bottom, we have this Databricks SCC. This is a private backend endpoint. And below that is encryption. We have 3 types of encryption in Databricks. This is called the services encryption. It means that your notebooks, workflows are encrypted with your key, with customer managed key. Next, we have disk encryption. The clusters that you are using in Databricks workspace, they are encrypted using your customer managed key. And the same for DBFS, Databricks file system. Your file system used in this workspace also encrypted with different key. So now let's have deploy all of this configuration. We first run the second pipeline to create our groups and to create new catalog. All right. And next, the third pipeline to create all those encryptions, to connect new group, and so on. Okay, now after the successful deployment, we have like multiple new resource groups with this middle name called dev. Dev is our new environment. So let's take a look what we have. This is like a network interface with private endpoint for Databricks cluster connectivity, our data factory, and let's check out our Databricks. So we have all of these encryptions, as I mentioned before, DBFS, managed disks, and managed services. They are already configured. And our networking, we are only like, these clusters are accessing Databricks control plane using private endpoint. Now we have our cluster that would be able to access Unity Catalog, our RSQL warehouse, and let's check our groups. ADC 2024, and these groups had permissions on this cluster. Let's check like account users can restart. Right, that's correct. That's what I mentioned in Terraform. And catalog, we have created this ADC 2023. So basically, let's back to our slide. We have completed our task and successfully provisioned new environment, like within, to be honest, like 10 minutes. 10 minutes, like on environment. Quite impressive, right? So I'm ready to answer your questions about this product. Let's check our chat.
Yeah, Oleh. Yeah. Thanks.
Cool.
Thanks for a great demo. I think this is not the only tool we have in EPAM for our acceleration purposes, but I have some tricky questions for you, actually, coming from the chat. So, two similar ones. Where is the money? So, how much actually you can save with Accelerator? What value it brings? So, why can you do all this manually? Like, can you briefly summarize what is the value of it?
So basically, anybody who has deployed Databricks into his own virtual network knows it's like a big headache. There is a lot of prerequisites, a lot of like small things. If you forgot at least something, everything like will crash. And this like tool is designed to make this consistency of your deployments, and how it saves like the money. You asked about money. To develop such tool from the scratch, or at least like some your iterations, it requires time, not like even 2 months. There is like some pre-built tools, but they aren't on the same level as this one. The huge team of people and human work stands behind this product, and we're still working on it like every day and supporting it, right?
So actually what you're saying that EPAM invests to save money for our clients on these tedious and common tasks of deployment of Databricks infrastructure, right?
Exactly, Ivan. Yeah, right.
Yeah, okay. But doesn't this accelerator, there is another one tricky coming from the chat. So it's actually a bunch of scripts, right? So it doesn't automate tasks. It doesn't, act as a copilot. So, is it a self-service, or this only can be used by, some EPAM engineers coming to a project?
So I mentioned before about like self-service. This is a completely EPAM-owned product, and it is accessible for EPAM engineers on new projects. We provide some pipelines to be exact, for Terraform deployment for some demo cases out of the box. Like there is some degree of automation. For example, like some cron jobs, you can deploy workflows to the Databricks and schedule, like trigger them. So I guess we have some degree of this automation, but to be exact, we are developed only the infrastructure. With regards to the data, you have to work it on yourself. We can work with you. We can discuss some solutions with you, but our team are primarily focused on infrastructure, and that's it.
Okay, so what you're proposing actually is a bundle of a team and accelerator solution. Am I right?
Yeah, right. So
okay.
It's yeah.
Okay. And personally, what I'm interested in. So, what are technologies are supported except from the Databricks? I mean, do you support Snowflake or Azure Data Factory? What is the technology stack?
So yeah, nice question. Thank you. We have some implementations of Snowflake. We already tested them. Maybe someday, there will be a release with Snowflake, management of Snowflake using Terraform. But you mentioned also the Azure Data Factory. We completely covered this service. We have CI/CD examples for this service. We support self-hosted integration, runtime deployment automatically. We support these endpoints, repository management. So pretty much, I'd like to say that ADF is covered. And also all these small services of Azure, the secrets, key vault, storage accounts, and so on,
Okay, so Azure is pretty much covered. And what about AWS and GCP? Do you have some developments in that direction?
Yeah, thank you. So with regards to GCP, we have the version for GCP that is working with Databricks, supporting Unity Catalog. You can check out it too. AWS, we working on AWS. This is on early stages. So maybe next year, early next year, we will have another platform like this for AWS that completely covers all Databricks features within the AWS cloud.
Okay, great. So it covers a lot. That's a great work, Oleh.
Yeah.
Okay. So for now, I think we don't have any more questions in the YouTube comments or Q&A portal in the Where community. So I think we can wrap up this wonderful session. One more question for me, which could be of interest to our viewers as well, Oleh. So where can I find some information about this tool, EPAM Data Landing Accelerator? Is there some website, a portal? Where can I read about it?
So later, I will share with you our knowledge base page when you can check out all our documentation, and also our repository when you can find the latest version and get acquainted yourself with it.
Okay. Thank you very much, Oleh. Thank you for your work. Looking forward to building more and more data platforms with your tool in our recent future. Okay.
Nice.
Thanks all for viewing us. This is Engineering Stream, which is part of our 2023 Autumn Data Conference. Don't forget about the quiz. You can win prizes there. Find the links in our YouTube stream descriptions and our Q&A sessions. Also, please share the information about our conference in your social media with the tags on Twitter or Instagram with the hashtag Autumn Data Conference to win pleasant prizes. Now we will watch a small video introducing one of our tools, which is part of the Mykolaishyn family accelerators. Please show the video.
Hi, my name is Mykolaishyn and I'm responsible for growth and development of data analytics branch in Ukraine, where data science, machine learning, and AI take the spotlight. It's a great honor for me to be part of Autumn Data Conference 2023. Here at EPAM, we contribute a lot in people's development, their upskilling into cutting-edge technologies to empower data science, machine learning, and AI capabilities. Throughout the conference day, you may realize the true transformative power of data science in AI. Ukrainian team of data scientists and ML engineers organically complement our global team, 400 enthusiastic professionals. Our customers highly valued our expertise, dedication, and diligence. We crafted more than 10 unique educational programs for our people to become better in the field of data science and AI. For our customers, we developed more than 20 AI enablement programs to respond to their needs way faster. I'd like to thank you for attending our conference today, and let's harness the world of data together.
Cloud data migration is a complex process of transferring data to the cloud from sources such as data warehouses and databases and modernizing their associated data processing pipelines, reports, and legacy applications. EPAM is ready to support clients end-to-end from comprehensive migration assessment to migration execution and reconciliation using our tools. One of our signature solution is Mykolaishyn Analytics. It speeds up the discovery process with automated inventory scanning and analysis and the automatic generation of a migration roadmap. Mykolaishyn Analytics allows to discover all inventory and optimize the scope. Unlock the boundless potential of your business together with us. Contact us on epam.com.
Okay, so looking forward for our next talk with Paul Gesiak on AI evolution. We'll start in 10 minutes or so. Please stay with us and see you later. Hello and welcome back, everyone, to our data engineering stream at 2023 EPAM Data Conference. Glad to see you with us again. Don't hesitate to press like, share, or subscribe on our YouTube channel if you're watching us through YouTube, of course, if you like it. So, the next talk is about the world of the year, AI. The talk covers how generative AI like GPT-4, Claude 2, or LMA2 deals with challenges like bias and misinformation in AI. Paul will be talking about concepts. Paul Gesiak, who is driving ML competency in the EPAM's data practice, will cover topics such as theory of entropy and how it improves AI models, and stresses the importance for further research in generative AI. Claude Shannon, the father of information theory and transformers, is a topic of the next talk. Please, Paul Gesiak, Director of Data Analytics Consulting in EPAM, you are welcome to speak and share your thoughts on that.
Hello, everyone. I hope you can see my screen right now. Wonderful. Okay, so let's start. So I would like to start with the key concept. Then I would like to do a quick overview of the current state of the generative AI as we see it from our practical perspective. And then in the end, I would like to leave some time for conclusion and for questions. So let's start with what everybody have noticed for over a year plus. That was a massive revolution. So I just remember before 2022, there was a joke, what is the difference between machine learning and artificial intelligence? And the answer was machine learning was written in Python and our AI was written in PowerPoint. And everybody were having fun with this kind of definition of AI. However, 2021 came, 2022, and then this joke is not funny anymore. Actually, we can rewrite it in a slightly different way. So the difference between machine learning and AI is now very, very different. Machine learning is now written in Python still, but it's actually being written by AI. I mean, not fully, but occasionally. And AI Copilot is actually writing PowerPoint. So for this, I don't know if Copilot will be good enough to finally figure it out, how to copy-paste text with preserving format from Microsoft Word to Microsoft PowerPoint. Or maybe we'll need to wait for general artificial intelligence for this. But nevertheless, Copilot is very real in Microsoft PowerPoint. So I would like to propose one way of looking at the generative AI space. And I would like to look at this from the perspective of information theory. Why I want to do this? I found that information theory helps me develop the simple mental model to understand this domain, and hopefully this could also serve as a simple explanations and examples. And how we will be doing this? We know that for each complicated problem, there is at least one simple solution that's almost certainly wrong. So this may be the case with my attempt of explanation. However, we also know that all the models are wrong, but some are useful, as George Box mentioned it at the beginning of computational statistics. So maybe I would be wrong, but useful. So let's go further. So why information theory is, for me, the most useful lens? It comes from physics, from entropy. Obviously, entropy in information and entropy in physics are very different things. Nevertheless, the equations for entropy in information theory, called Shannon's equation, was very similar to the entropy equations from physics. This is why it started a little bit like a metaphor and now evolved in parallel to the entropy in physics. Fundamental for computer science. So we know that information theory basically sets limits and sets rules for computer science in information transmission, in data processing, data compression, machine learning, and many different subdomains. And another interesting aspect for information theory, particularly for compression, I found that compression is becoming very useful in definition of machine learning and also in definition of intelligence. So the better we can generalize, the better we can compress the information which we are getting from the outside world into some rule of thumb or some knowledge. And with this knowledge, the more knowledge, the better compressed knowledge we've got, we can say that the more intelligent we are. And that's similarly, we can tell it about machine learning models, including large language models. So the better they can compress learning from a large amount of data, the more intelligent they are, obviously. We are not comparing here human intelligence with machine learning intelligence. However, I'm pointing here that definition of intelligence as compression is useful because we can attempt to use it for both for machine learning and for human or animal intelligence. So let's start very quickly with recap of entropy for all computer scientists there. I do apologize, and for mathematicians, my understanding of entropy is very utilitarian here. So entropy in information is what tells us, it tells us basically about number of disorder or uncertainty in the data. So the plot below shows us the binomial distribution. So when we are flipping the coin, if the coin is bent and it's more likely to come head than tail, this kind of coin will have much more entropy. Let's say that this bend splits around 80%. So we will have entropy around 0.7 with 80% probability. If we've got perfectly fair coin, the entropy is highest because we've got the least amount of information in the system. So it's basically our prediction if there will be head on tail is as good as random by definition, and our level of surprise if it comes head on tail is not very big because we are expecting with probability 50-51 or another. However, with a bent coin, then we are expecting, let's say with probability 80%, that it will be head. So if it comes tail, then our surprise is significant because there will be only 20% probability that the tail will turn up. So in this case, we learn from this kind of event much more. We had much bigger surprise, and in this way, the system, overall system, had here lower entropy. So in this way, if we look at the machine learning, we can focus on using entropy to optimizing algorithms. So here we can understand the amount of uncertainty or disorder in the data, particularly at the training stage of the model. And then we can use it to improve the model. So it's basically, we'll start feeding model data with less noise, And then we can also calculate that data in the same domain. It does not cancel each other, so it doesn't give opposite signals to the model. And in this way, we can help model improve this type of active learning, we can call it. Then temperature parameter, obviously, temperature refers very closely to the entropy from physics, but here we are obviously increasing the randomness of the prediction. So the rule of thumb is that our predictions will be probably more random, maybe more creative or more unexpected, but less reliable. So as a rule of thumb, if we are generating code, we want to have the temperature of large language model prediction very low. If we are trying to generate random idea for, I don't know, sci-fi novel, if somebody will be doing this using large language models, then we would like to have the temperature high. Maybe one more aspect of the use of entropy in machine learning. So it's here preventing model collapse. So this, we've got lots of examples, particularly when we are taking larger foundational model and we are trying to fine-tune the model. We know that sometimes fine-tuning augments the weights of the model in the way that predictions are completely collapsing. And this process can be intuitively understood also via entropy, because when we are adding the data for fine-tuning, which is adding too much disorder to the weights of the model, and particularly when we are using techniques like LoRa and QLoRa, which are obviously dramatically increasing the importance of our fine-tuning data, then we can observe the collapse of model performers. And this is an example when the entropy is taking over. And another aspect, my favorite, is about compression. Again, it's a way of looking at machine learning models. It's not really a definition of machine learning models as a compression. However, if we think about this, then what the machine learning model is doing, just trying to take all the input data and compress it into its weights. Obviously, the compression is lossy, but the model is trying to generalize some common patterns in the data, so it doesn't have to persist as every single bit of the data. So the better model can perform this compression, the more useful we find it. And the major breakthrough with large language models, probably from BERT and onward, or at least when I have noticed it, is that we learned that if we throw enough natural language, the model will be able to compress the open text data by distilling the not only syntactic but also semantic rules from the data. And large language models now, we're not used to this, but it's still amazing that they can generate not only syntactically correct predictions, but also semantically correct, or at least sounding semantically correct. So this is fascinating. Again, if we come back to useful aspect of intelligence, if we try to use compression as an useful aspect of intelligence, then we can say that the models which can compress the rules, semantic and syntactic of natural language, better, they are models which can be more intelligent here. Again, I don't want to go anywhere near general artificial intelligence. I'm just pointing into one aspect of some similarities between natural intelligence and large language models. And here on the right, obviously, we see the difference between entropy and the potential size of the compression. I mean, this is the representation of Shannon's limit theorem. So here we are assuming lossless compression, but obviously we know that lossless compression and lossy compressions are correlated. So in this case, the smaller entropy, it means that there are more rules underlying the distributions in the data. So it means that we will be able to compress potentially this data into smaller package. So again, less entropy, more learning, more generalization, more entropy, less learning, more likely for catastrophic model performance collapse. Okay, so thinking about these two aspects, compression and entropy, just recap what just happened over the last few years. So this is my favorite paper. It's my favorite also because it's kept up to date. So if you have time, I strongly recommend you to look at this and keep it in your resources. It's a survey of large language model by Schraum and colleagues, and they are doing a fantastic job in analyzing trends in development of the large language models and distilling it into set of very useful metrics and information summaries. So here we see the progress of large language models. Most of these models, if not all, are based on transformers architecture, and here also the models which are with yellow background, these are the open source models. So we can take them and hopefully use them for either hobby or even sometimes for commercial applications. The models which are not highlighted, these are the closed source models. So these are models like ChatGPT-4, etc. And here the development is very strongly weighted towards open source, significant open source models. And it's not only at the beginning, but it's still every month or two, we see a new development in closed source model, in open source models domain. And I would like to dig deeper because I think by now there is a divergent into two paths of the evolution of the commercial closed source large language models and open source models. And I would like to focus on this aspect a little bit. So closed source models, here they are obviously massive. So number of model parameters, which is basically the size of models, the physical size of the binaries, which model file is saved in. It can be expressed in billions of parameters, and the closed source models, by now they are roughly over 70 billion parameters, but they are now approaching or even exceeded 1 trillion parameters, and this is on the parameter space. Obviously, the amount of compute and pure hardware you need to have just to run inference of these models is very significant to train or to pre-train these models as the foundational models. And these are tens of millions of dollars investments right now. So this is outside of the capabilities of majority of open source or even commercial companies. They're only the largest, the best funded companies who can afford for pre-training new models. And here, also, let's look at the size of the pre-trained data. Obviously, there is a big bias here because a lot of latest models like GPT-4, they are not announcing what data and how much of the data it's been trained on. But nevertheless, we can just assume that it's under 2 billion tokens with this caveat. So what we are seeing here, so models which are very big, very expensive to train, expensive in inference phase, with under 2 trillions of tokens in the training data set. What it means that larger models, they can represent a less lossy compression because we've got larger amount of bytes to compress our training data into, so we can be more generous in maybe integrating knowledge, even individual facts from the knowledge. We can be also, you can argue, we can be more detailed with generalization. And these models, they are becoming relatively decent in terms of retrieval. Obviously, we cannot still rely fully on the retrieval. The hallucinations are still very potent. I would like to dive into why I think the hallucinations are still potent. I mean, not only why we think that hallucinations are still potent, but nevertheless, you can rely on some general knowledge to be retrieved by these models because of their size and because they can integrate so much more knowledge. And let's look at the open source domain. So these models have been constrained by the size of the largest instances on cloud providers, infrastructure. So here, what we want to do, we want to keep these models rather under 70 billion parameters, and ideally around 7 billion parameters, which means that we can run inference on the largest A100 or H100 GPUs, single GPUs, so we don't have to parallelize it. But also, these models are being generated in several different versions, usually from, let's say, 7 billion parameters to 70 billion parameters. And this is because different use cases requires a different accuracy of the models and also different expectation in terms of budget for GPUs. So this was like a natural constraint of the open source models. So don't go into very big models. We don't go over 70 billion parameters. But what's happening with the training data? Here we see that training data, at least what we know about the training size of the training data with the commercial models. With the open source models, this training data is the same, if not the bigger. I mean, there are some of the models reporting even over 2 trillion parameters in the training data. And also from the Llama 1 by now paper, we know that they are focusing much more on longer training of these models with a relatively large amount of data. So this is becoming a different strategy than large commercial models. So we've got constrained size, but we are trying then generalize more. And we are trying better generalize by having the same or bigger amount of training data. And by training longer, we are hoping that we are going to give model more chances to generalize. So we are going here for higher compression. We are integrating far less knowledge. We cannot afford to integrate a lot of knowledge byte to byte, but we are trying to generalize as much as we can of the rules from this knowledge. So we can say that this compression is much higher. It's probably much more lossy. This is why I wouldn't recommend to rely on any information retrieval using the open source models. But nevertheless, there is a hope for better generalization. And this is very interesting what will happen later on, because we've got this need for size when the large language models, the commercial, will be bigger and bigger with more integrated information, and need for speed when the open source models, they will probably stay in this constraint limit by the hardware, but we'll be trying to train them on and to make them generalize more and more knowledge and rules. So we will be able, hopefully, to make them more intelligent. And this divergence, I just want to focus on the most significant moment in this divergence between these two evolutionary paths of open source and closed source models. So it was, I just call it an alpaca event, because I remember it was a quite dramatic event when Llama model has been released. I mean, the weights of the model has been released unofficially through some chat channel. The model hasn't been officially released, but the weights were already there. People were experimenting with this model, and one of the researchers took the Llama model and then used GPT 3.5 to generate a lot of very high quality biosynthetic data, fine-tuned the Llama model, called it Alpaca, and demonstrated that the performance of the Alpaca model, so of this fine-tuned Llama model, is becoming comparable with ChatGPT 3.5. And that was a dramatic moment, because what he proved is that he can dramatically improve performance of the model, which he can run on relatively small budget. The fine-tuning here, I remember it was just under $200. So comparing with any other foundational model costs, this is pretty much nothing. And that started all this activity around taking usually Llama-derived models and moving them and fine-tuning on synthetic data, on the real data, sometimes with human feedback, and then trying to develop some specialized models out of this. And the results are very surprising. I mean, I don't have separate slide for example, Gorilla model, but Gorilla model is amazing in terms of how reliable the inference of this model is, and how interesting was the fine-tuning to the specific domain. So if you've got time and you haven't seen the Gorilla model and Gorilla paper, strongly recommend this. So now I would like to talk also about a few aspects of the large language models right now, which are unsolved, and they still limit the production implementation of a lot of large language model-based applications. And one here, this is reinforcement learning with human feedback. I know that this is becoming less prominent technique, but nevertheless, it was amazing what this technique did to the popularity of the large language model. We can say that reinforcement learning with human feedback, it was the single technique which was the most responsible for the overwhelming success of ChatGPT, because we had the models which were comparable with this model before, but only when OpenAI focused on the usability in the interface and train this model, fine-tune this model on the human feedback, this model became extremely easy to use and extremely surprising. We don't have to And you should teach this model what we are doing, that this is the dialogue. This model knows by default that this is a chat, this is a dialogue, how to behave. So that was fantastic breakthrough. But there come disadvantages with this reinforcement learning with human feedback. So one is the fact that the model wants to be much more truthful than, much more pleasing to the user than truthful. And this is one of my favorite examples. I like to test models on the liar's paradox. So if I'm lying, that I'm lying, do I say the truth? And obviously, zero-shot learning here is the model. Each model would just explaining me that this is the liar's paradox, and basically my question doesn't make sense. But if I constrain the model now, okay, the question is the same, but now please answer only yes or no. The model is going to answer one of this, and very often it's no. But why it's answering no? It just first wants to please me, so it's just giving nonsense answer based on my request, even in contradiction to the previous response. But also at this point, I can decide if the model will answer yes or no purely by which of the options is the last. So if I rephrase the question and just please answer no or yes, then again, more likely will be that the model will answer yes, because obviously this is the last token, and this token is more correlated with the response. So these are the problems with reinforcement learning with human feedback, and just generally models which are very user-friendly, but by this they are trying to please the user much more than trying to be truthful. For this reason, not only for this reason, but obviously hallucinations are a big problem. So now we have ways of dealing with hallucinations, mostly by using retrieval augmented generation and techniques like this. But nevertheless, there will be this balance between truthfulness and usability for a little bit. Maybe something will change dramatically, but right now I don't see any promise here. And very quick overview of the problems of metrics with large language models. You probably noticed the models which have fantastic metrics on the Hugging Face leaderboard, but they are pretty much useful for any case you want to use it. And other way around, models which are not very good, but they are specialized models. They have actually fantastic performers on some very specific tasks. And this comes with the crisis with metrics. So the crisis with metrics first has got the origins in the fact that the metrics validation of the large language model is very difficult. We don't know really what these models are doing. It's difficult to evaluate performers in any other way than by just using a golden data set. So it's basically we've got golden set of answers based on specific questions. We are expecting these answers are as a gold standard. They are obviously generated using human experts, which is very expensive. And then we are comparing the answers to the answers generated by the model. There are some ideas how to do this in the way that we don't need to have a golden data set, but I haven't seen anything yet which is working in practice. So again, in terms of validation model, the only thing which is working is just, unfortunately, supervised learning methods for validation. And then obviously validation of these models is expensive. The models are sometimes overfitted. So if we are using in our golden data set the questions and answers which have been in training data set, then we are basically not testing any model. We are just testing how good the model remembers the training data. And interpretability with large language models is pretty much abstract. There are some interesting academic research, but it's still a massive challenge how to interpret what model is doing. And now there is a completely different problem. It applies mostly to the open source models. So this is the ranking gaming. And this is sometimes it's intentionally, sometimes it's intentionally. So we've got on Hugging Face, we've got the leaderboard of the open large language models. And the leaderboard is basically done in the way I described. So there is a subset of each training data set, which is preserved for testing. You shouldn't use it for training your models. But, you know, if you forget not to use it in your large language model training or fine-tuning, you may find yourself that this version of the model is much higher in the ranking. So the more you forget about this, the more you're being rewarded in the ranking position. I mean, I'm being sarcastic here, but if one model started doing this, now we are using a lot of synthetic data, which is generated by other models to train new models. So this model is started poisoning with already this data leakage, that test data leakage, other models, and all metric becoming irrelevant. There are some ideas what to do with this. So should we do like in Kaggle, that there is a validation data set which is not in open domain, so only trusted environment persists this test data set, and we are using it only for testing. It's not available for training. Or should we use some new benchmarks for evaluation? But it will be a perpetual problem. So here, again, don't trust the large language model leaderboards too much. They are useful for some ways, some other they are not very useful, but whenever you want to use large language model, always validate it yourself if on your use case this model would be useful. And very quickly, I wanted just to mention the open questions with the large language models. So explainability and interpretability. Now we develop few methods with classical machine learning where we could sample and almost brute force the classical machine learning models like random forest and have some inference or some good guess what in the input data set contributes to the output. But with the size of the large language models, brute forcing or sampling, this way the data pipeline is not really feasible. It will be just prohibitively expensive and computationally prohibitively too difficult. Then uncertainty and no unknowns. So this is this problem that the model theoretically can generate some confidence. So it just gives you a probability how likely it is that the next token will be this particular word, not another word. But still, we don't know if this probability comes from the overfitted data. So there is actually some fact somewhere in the data, pre-trained data set, which has been memorized by the model, or it is because the model generalized some rules. So it's actually generating inference not based on the overfitted data set. And in the same way, if we ask model how confident it is about its output, the model gives us some indications of the confidence, but here again, we cannot be certain. Is it the confidence based on the memorized knowledge or based on the inferred generalized knowledge? Obviously, the first one would be much worse than the second one. Data limitations, funny, this is not the cost of training, not the size of the models, but quality data access is the major limitation in the progress in improving performance of the large language models. And emerging behaviors. So this is something which I think there are some hopes that this may lead us to artificial general intelligence. Again, I don't want to discuss artificial general intelligence. Nevertheless, we see that more and more compute, which means more and more resources we put into the models, the new, more interesting behaviors are emerging from the model, which is very interesting. Okay, I was talking for a little bit too long than I was expecting. Maybe we'll open it for questions in the last 5 minutes.
Yeah, thanks, Paul. Yeah, I think we still have some time. So if you haven't covered some of the particular topics, so we can, we can still cover them. I don't know if you have, but if not, yeah, let me see if we have some questions in the chat. I don't see too much, frankly speaking. So I think if there is something that you maybe want to address more specifically for the rest of 5 minutes, you're very welcome.
Mm-hmm. Okay.
I see there are comments like about that your talk is extremely interesting. Yeah, but unfortunately, it's not a question that could be raised. It's not in question, I would say. Yeah,
Yes, I think that the way I'm trying to propose to understand these developments in large language model and this now parallel evolution of the commercial large language model and open source large language model, using compression and entropy here helps us understand why some models are smaller, some models are going for the size. And maybe I will mention all the area around reliable retrieval, because right now in pretty much all production level application, we are not using large language model on its own. We need to have a retrieval component, and the retrieval component is usually linked to some databases. Most likely it is semantic index done by embeddings, but there are also problems with this. So nevertheless, we always want to do this in two sets. So we are retrieving information with the reliable source, and this we know how to do much better than validating large language models, and then only based on this information we are expecting from large language model to give the right answer. So it's basically to put it all together into the right answer. Nevertheless, there is a problem particularly with the semantic index-based retrievals, because here if we are trying to introduce a brand new concept to the model, we can retrieve, let me give example of the Autogen, the autonomous agents library by Microsoft. So if you'll be asking ChatGPT-4 about autogens, it will be just making stuff up based on the name. It doesn't have any recollection. If you give it the documentation of the autogen, it's going to generate you the code. But unfortunately, if you start asking about generating novel code based on some few autogen examples, it will be hallucinating, because it doesn't have integrated concept of autogen, doesn't know in its training weights, doesn't know what autogen really is. So if you do not introduce at least some expectations, some explanations in few short learnings that autogen is something like it used to be before, I don't know, the agents in LangChain, and use it like agents in LangChain. It just has got different syntax, and so you will have to explain this model in few short learning to do this. Otherwise, it's still RAG would not be a solution here. Sorry, I don't want to go over over.
Yeah. So you still need humans to put these pieces of knowledge acting as a bridge. And the most classical question from the chat, I think, nowadays. So what is your prediction, Paul? Will large language models replace developers in the near future, or maybe 20 and 30 days? What do you think about that?
Oh, no, it's this which makes developers much better because it does not replace thinking. You have to still think very clearly about the problem, and only if you give a clear instructions, you can have generated code. But if you give very clear instructions to the bright intern, it will also write a very good code. So it does not replace thinking, particularly system thinking. But my prediction is more about agents. So the next year there will be talks like we had about the last year with large language models, was what created this massive popularity of autonomous agents and what was the breakthrough, because this is coming big time this year.
Okay, Paul. So thank you a lot for this insightful presentation. I think there was some heavy-duty content we heard from you. Very nice, very deep. Let's hope we will all benefit from the development of AI technologies in the near future, especially in the engineering competencies and our ability to deliver impactful things to the humanity. So thank you, Paul. Let's wrap up on this. And we'll be back after a short video.
In today's tech and data-driven world with a vast amount of accumulated data, it becomes crucial for enterprises to utilize data effectively and innovate through data. And EPAM is here to support our clients in this journey and offer best solutions. Each of our offerings is a combination of capabilities, a set of experience-based solutions, capacity, a team of cross-functional experts, and finally methodology, varied implementation guides, and templates. We are ready to support our clients end-to-end, from data platform build to modern generative AI capabilities development. Data Factory. Data Factory is a data product-centric framework which consists of 4 pillars: data strategy, data product mindset, data platform, operating model, driven by business and enabled by technology. We have handbook and templates, trainings and accelerators to speed up the delivery process. EPAM Data Landing Zone is an instrumental tool designed to accelerate the management processes of data project infrastructures. Unlock the boundless potential of your business together with us. Contact us on epam.com.
Hey, welcome back everyone to our engineering stream. This insightful talk by Paul Gesiak on AI and the evolution of AI concludes our engineering stream. But EPAM's Autumn Conference is not yet over. We will have soon a very good roundtable, which some of our leaders from the data practice will take part in. So, roundtable with technical leadership such as Martin Lepatka, who leads data science efforts in EPAM, Mykolaishyn, who is CTO for energy industry in EPAM, Valentina Ivleva, and Oleh, who leads competency development in EPAM's data practice, will start soon in the main channel, architecture and vision channel. So to continue watching us, please click the links which are provided in the We're the Community platform in QA sessions environment and in the description of our YouTube channel. I also remind you that we had our quiz during the talks on our streams, and thank you for the dozens of you who have participated in this quiz. And the quiz now stops, and we will share the results soon. Don't forget to share the information about the conference in your social media using the hashtag, and please stay with us and join our moderated discussion. And by the way, the roundtable will be moderated by the head of our data analytics consulting practice in Ukraine, Dmytro Leskovsky. So let's watch it together and have a nice day.